Hello there. Welcome back. All right, so yesterday's session was the longest one, 6 hours. I didn't even know that I can do such a long session. Today's one will be shorter. Yeah. So yesterday's session was one that you can watch 2 or 3 times, maybe. Um, you could search for a tool that cuts the video and only shows you parts where I'm actually talking, and like if you take all of the pauses, I'm pretty sure you can like save maybe an hour or something like that, or even more. um yeah, and I will actually probably do something like that at some point when I want to compile all of these videos into like a course. um but I'll see. Just and I will upload them as a playlist, and it will be like short, not short. It will be the more condensed version of it. Okay, so let's take this thing here. This thing. One second. Yeah, so week 2, day 4. Let's see how the stream's going. All right, excellent connection, it says. So we have like 24 new subscribers since yesterday. So we went from 9 to 33, or yeah, 24, right? Yeah, because I posted on Reddit and on some Discord servers about yesterday's session, so that as many as many people as possible can benefit from it. Okay. Hello. And I guess we can even start now, so we won't wait. Like sometimes we even waited for 15 minutes, but now we might just wait maybe 2 minutes and start. Yeah, and I keep forgetting to record the the meeting as a backup here in Google Meets. So let's do that now. You know, like I trust YouTube, but you never know what happens. Okay. Hi, Peter Parker on YouTube. Okay. So I guess you saw the yesterday's marathon stream, and I know people like there's a guy George Hotz that he who also like recently does long streams, and he does like 8 hour streams and so on, but he's more of a like he's doing it more like a freestyle thing, so it's much easier. But like I had a script that I had to follow, right, to be able to go through all of the slides and all of the concepts, and yeah, it was pretty hardcore. Um, yeah, I guess we can start. Let's wait just one more minute, and at the same time, I'll just look into some things here so I can just remind myself what I've done here. Yeah, so 30 more seconds and we'll start. So let's see. Yeah, so at the end of the current, so I mean near the end of the current session, we'll go through a minimal Tetris game, and depending on the remaining time, I'll either show you what I already have, or I'll create them, um, you know, from scratch. Yeah, but I don't know how many lines of code I have here. It's maybe like 800 or something like that. Or I think there's more. Yeah, okay. Good. I guess we can start. Let's see. And let's first put this thing here. Let's go here. Oh, Peter's watching from Kenya. Man, I'm loving it. Yeah, I'm so happy that you're here. uh, Louis Baz says, It's my first day here, but I'm ready to catch on." No worry, man. You can watch the streams at any time. They are recorded. Like, there's no rush. There's no like 3 days remaining to sign up or something like that. So you can watch them at any time. Yeah, good, good, man. Um, okay, so we are at week 2, day 4. And let's see, Mike is going, everything is going well. So yeah, finally I mean, we did some coding in Unity, but now it's like the official slide, the official day of actually doing more of our Unity coding. And this is like the yesterday's session and today's session are actually the things that I'm the best at. So I'm not an expert animator or level designer or gameplay designer. Or I mean, I'm doing well there, but my strongest points are here in coding. And yeah, hopefully I can uh, give you as much value as possible in this like 3 hours or 2 hours. Um, yeah, so Unity uses C Sharp, as you already know. So there are two main scripting backends, Mono and IL to CPP. And you just need to know that there are just two settings here in Unity where you do Command Shift B or Control Shift B on Windows. And you go to player settings, and I like to pin this thing here. And you have like desktop selected, and go to other settings, and you have this thing here, which is Mono or IL to CPP. And there's a lot of things that we can talk about these things, but most of the time when you will build the game and create an executable for it, you would select IL to CPP. And I think something has to happen here. Scripts to be recompile, or yeah, they don't, but doesn't matter. Yeah, and but when you want to build your game many times, you would use mono. Like if you want, I don't know, build like 2 or 3 times per hour because you are testing stuff and you building and then testing and again building, you'd use mono because it's faster. And IL to CPP just takes a lot more time because it's more optimized and so on and so forth. And as a general rule, no matter your platform, like Windows, Android, iOS, Mac, Linux, WebGL, you should use this thing. And also by using that thing, you also will have more predictability between platforms. So it's not like you'll have some bugs on Windows and you won't have them on iOS or something like that, or Android, right? There will still be stuff like that, but if you keep the same backend everywhere, it will work fine, right? And you can, of course, for example, if you want to give your game like if speed is more important than um, uh, specificity. So if speed is more important than having a perfect or a consistent experience among the platforms, then you of course can just go and build the current scene or whatever the current scenes or your entire game with mono. It will build faster, and maybe you want to just send it to your colleagues at work or whatever, depending on your project and how you're working on it, right? So this is a thing that allows you to move faster, right? And you cannot play a game that's built with mono on iOS, I think. And I think even Android now has this restriction, but I don't know for sure. Okay, let's skip it. I don't know. It was mono. I think it was mono, right? And there's this thing, .NET Standard and Framework. So try to use .NET Standard as much as possible. And I think it's the default one, because it's standard. Yeah, this thing changes from Unity version to Unity version. And yeah, currently you are like at standard 2.1. This is a very cool thing. Just try to use it. And there will be some I don't know, a very maybe complex asset or plugin that you are creating or you are importing, and it will need you to set .NET framework, but only set it there, right? It's like a more advanced set of instructions. Good. Yeah, we'll use Mono for now. Yeah, and also .NET Standard 2.1. So back to model behaviors, as we did in throughout this course, you have heard about them quite a lot, and you should already know what they are. But yeah, so what they are a script that you can attach to your game objects, right? So you create a class like this, you added some properties, and you add some functions. For example, this is that are special functions. So a function with the name start will be recognized by the Unity engine, and then it will be called on your object when the object first appears in the scene, right? And this is a message just to show the value of this property, right? And because it's public, and because this is like a mono behavior, this is what it's called. When you attach it to an object, you can select it, and for example, like select the object where the script was attached, go to inspector, and you'll see this my property here, and it will be a number like this, right? This is like a number, it's an integer number, right? Why it's called mono behavior? It's I can go like the simple route and just tell like it comes from here, or it really comes from this thing, because the first scripting backend was Mono on Unity, and it's a very cool project. Like Mono, it's like a project in itself. It's a project that allows you to write C# code and run it on many platforms, and that's what Unity uses, right? And it had the Mono, and that's why it's called the Mono. And behavior, because this word actually describes what the script does. So it's actually behavior. That's like the most descriptive word, right? Because it's something you add behavior to your objects, right? They are not just plain rocks. They also have some behavior. And mono because, like I said, right? And that's their decision. And this is like from the very beginning since Unity 1, I think, right? Good. It's the base for our script. And a script is a bunch of code that allows you to control every aspect of the game object that it's attached to, but also any other game object or any other instance of a class that you have in memory. Doesn't necessarily need to be a mono behavior, right? Attaching it to an object suggests it's associated with or owned by that object. And that's all. Yeah. Yeah, so a component like this gives you a lot of power. It's like the most important class that you can use in C# in Unity. Um, it's like a bridge that you communicate with Unity, through which you can communicate with Unity, right? And no matter what you want, in probably 99% of cases, you would use a mono behavior if you want something that's gaming specific, right? Because that's what Unity does. It's a game engine. So mono behavior enables you to access that game developer tools world, right? Um, yeah, we only know about the start and update functions. But now we can put them in into like view them inside the whole life cycle of an object. And of course, we'll also learn about a few others. They are like, there's a lot of them, but I think we'll talk about like 10, right? And from those 10, you could probably uh, use in your first few years, maybe, I don't know, like 7 or something like that, right? And let's see, do I have them here? No, I don't have them. So it's this thing here. Let's see if I do it like this. Let me try something. No, I don't want that thing. Can I do this? Okay, yeah. No, that's what I want to do. Oh, okay. 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 Good. So I have it here and I think okay, I can do it like this. Good. So Unity's mono behavior lifecycle. So let's go to a mono behavior. Let's see, a simple mono behavior. Do we have it here? Week 2, day 4, Unity. My script. Components. My script. Yeah, they are actually here as well. I think we can also go to them here. But yeah, you see, this is my script, sample script. It's just very simple. It has a property which of type integer. It derives from mono behavior, and yeah, it goes through many phases, right? There are many functions like this which are called that are called like when the object is first created, then while it's updating, and like while it's colliding with other objects or just staying or whatever, then when you just interact with it, when it's drawn on the screen, um, yeah, and then like when it's destroyed, like when you either disable it through code um, or through just in the editor manually, right? Like this. This is like disabling it, right? And then when you destroy it, actually you either do it in code or you just like delete it here, right? Like this. Um, yeah, so I've created these things here and we'll go over them. Yeah, okay, so I'm mentioning it here. So awake is called before anyone's on enable globally, only once. And of course you would have to just go over them once and just read about them or just listen to them now, but then you need to go through them again because some of them refer to others, right? So for example, awake refers to enable, but and so on, right? You'd have to basically do at least 2 iterations. But yeah, let's just take a look at them just quickly like this. So we have awake, on enable, start, update, fixed update, late update, on collision enter, on trigger enter, on disable, on application pause, on application quit, on destroy. You have many more. So exactly like you have awake, on enable and start, they are kind of at the beginning of the life cycle, and their counterpart is on disable and on destroy. The same way you have like on collision enter and on collision exit you have, but I didn't use them that much. You really have to test it with your Unity version because they're buggy, but sometimes maybe you're doing something wrong and it's not really clear which is which, right? Yeah. good. So these are like it's an overview, but let's go deeply to it. So awake is called before anyone's on enable globally, only once. So when you first create an object, you usually do it through code, like instantiate. You'll have some prefab game object, right? And you'll the moment you do that, and basically you'll do this in some other class, right? And if that prefab has a script attached to it, of course the prefab's instance, so the new game object, will also have an instance, like a copy of all of the scripts and components, and including this one, right? And then awake will be called, and then onEnable will be called. So initially called before anyone's start globally. Then called anytime you re-enable the script or reactivate its game object after being disabled. Or its game object deactivated. Yeah. So onEnable is called after awake. I didn't write this here, but I'm saying it. So the simplest case, right? When you have only a game object, you instantiate it, and its awake is called, then its onEnable is called, and then its start is called. And the reason we have three of them is because, for example, onEnable is called, it can be called multiple times. So once when the object is created, but also once, for example, when you disable the object and you enable it again, onEnable is again called, right? And there are two flavors to this thing. So here you have, let's say you have the events. I don't know. You have this image. So let's say you have the script here, and actually, oh, it's called w2d3, but it's d4. Let me quickly. I don't know it. Because I pushed the days, I pushed them. And I know it takes a bit more time to these things here. Okay. And what's happening here, man? W2d. Okay, so we're here, and we have to also rename this thing. Yeah, let's do it. Yeah, so it's 30 seconds pause. One. Because I'm referring to this in some places, and I don't want to get you confused in the future when you're looking at this, right? Okay. So I cannot refactor it. Okay, so I really think for Mac, Rider is the way. I didn't use Rider, so Rider is an alternative to Visual Studio, which is better, but you have to pay a license. And yeah, you have to pay a license. And yeah, that's it basically. Because I see like Visual Studio on Mac, it's kind of fussy. You cannot refactor stuff. And refactoring means that you go on this and just it should work like Command R. Oh, now it works, and then you can change it, right? I mean, you cannot change this thing because it comes from the base class, and it's a Unity thing. You cannot change it, but you can change it here, for example. See, clicked. What? Didn't work? Yeah. I won't go into it now. Okay. Good. So we've changed those things. Uh, where were we? Oh, yeah. I wanted to add the script here. Add my script. Yeah. And just ignore these buttons because we'll be adding them later. They are basically they shouldn't appear here. They are appearing because of another script that does this. Yeah, so you have the script here, and for example, you create the object in at runtime, so it pops here, and its awake will be called, its on enable will be called, and then I think the next frame, the start will be called. And then if you go here and disable it, or you do it through code, like this, like game object, and the game object it's referring to a property like this, but which is defined in the mono behavior in the base class, and that's why this refers to the object itself, so the whole object, right? So game object dot set active false, and this is the equivalent of just checking this thing here, unchecking it actually, right? And when you do that, on disable is called, right? Or when you do it here, on disable is called as well, right? Let's play it actually and see. Yeah, well, all of these things are called, right? Update, fixed update, late update. Let's disable them for now. So you had the awake, see? It's called before on enable globally. Called at init if enabled or when first enabled. Okay, this is the on enable. Okay. Then, I mean, this is a thing that's, just ignore it for now. Then we have start, which is called before anyone's update. And I don't know what disable was called. 1 second. Oh, yeah, because we're actually disabling the object in its start function. We're disabling itself. It says here. So in start, we did something, and then immediately on disable was called again. So we didn't even need to disable it from here. It disabled itself, right? But when we enable it, you see on enable was called, right? And when we disable the script itself also, on disable is called again. So on disable is called when you either disable the script or its game object. And the rationale is if the game object is disabled, then no script should execute stuff. Like scripts should go like in standby mode, right? Yeah, so it's also, and you'll see this, like if we just uncomment all of those things, they are updates, right? They are called once per frame, and we are running like 200 frames per second, right? Good. And when you disable the script, it stops, right? So its update functions and everything stop functioning, right? or when you disable the game object again, right? So on disable is your proxy for just maybe you have, I don't know, you have a background thing that's executing there, and it's like once every 5 seconds, it fetches some information from database or something like that, right? And in on disable, you basically pause that function, pause that 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 functionality, that process, right? Because if the object is disabled, probably you don't want to do that and waste resources. Um, yeah. So that's awake, enable, and start. And you have three of them because if you have multiple objects, let's say you're already, for example, in this case, let's disable these things. And you'll really see how this works, how this work. Right, so you have two objects that have, so I basically just copied and pasted it, right? And you have like two objects which have this script, right? And they are different objects. This script is a different instance. Like if you go here, right click and debug, you can see instance ID 20,800, and I think this one should be different. Yeah, it's 10,950, and this is like an ID, right? This is the ID of the script instance. That's what I mean. It's even called like that, instance ID. So that's like an instance of your script. Like it's living in a way, right? Not lock, normal. But that's your script and another script. So now when we'll start the scene, you will see one call for each, right? Yeah. Actually, I should have. Let's do this because it will be easier to. Let's disable this. Okay, on destroy. Of course, let's also remove this thing. Good. So, I mean, I think I would want to just discard this, and let's just create a clean new scene. Yeah, this one. So we have two objects, and it's already here, the script, right? Good. We have two objects, we play. Good. So what are we seeing now? We see like this. So first awake it's called, then on enable is called, and probably this is for a single object, awake and then on enable. Then for the second object, awake and enable is called. And then this just don't worry about it. And then start is called for the first object, and then start for the other object. So you see that you can think about it like this. So okay, I want, so by default you should use start. So if you want to execute some code at the beginning of when the object is created, you do it in start, right? And only later, like if you want something, you want to execute something before every other script start, you declare the awake function, right? And you do your stuff there because this is the rule. Like all the awake calls are called, or the awake methods or functions are called before all of the start functions, right? In a normal setup, like in a setup like this. I mean, if the game starts as disabled, um, and that's everything you need to know at this point. Like all of the awake functions are called before all of the start functions for just objects that are all of them start as active with this check here, right? When they start at different times, of course, you can have like a wake of the first object or start of the first object will execute, and then if after 5 minutes you create an object, of course, its start will, or its awake will be called after its start. It kind of makes sense. And that's everything you need to know at this point. Yeah, and awake and on enable, of course, awake and on enable, they are called in this order, but it's like there, it's not clear, like it's not clear which objects awake or enable will be called, because they are here and probably there's a rule, you know, like maybe this one is called, or maybe the scripts with the lower instance ID it's called, or like this is the minus, maybe this is called first and this, but you don't need to rely on these details, right? If you're relying on them, you're doing something wrong. Good. So let's also do it this way. So let's start with this one disabled, right? So if this object starts disabled, let's see what happens. Actually, let's do this thing when we actually can even, you see this function takes a message and a context, which can be an object, and this is a different, so object, like system.object is a C# thing, but I mean, I don't know how to do this. It's one thing, but Unity engine.object, it's a different thing. It's like the Unity's version of the object. And of course, because the systems object, it's also this. It's the same thing. So this is an alias for this, right? And it's a C# thing. And this is a Unity thing. And in the same way that the C# thing needs some default implementation, you saw it briefly there. Right, I don't know, can I see it here or this? Yeah, it's something I cannot browse it easily. Yeah, it has some helper functions there, in the same way that Unity also needs some helper functions and so on and so forth, and this object inherits from this object as well, right? You can see it here, right? This is the Unity's object, and now it will disappear. I don't know why. Yeah, this is like picking inside Unity's internals. Okay, and everything in Unity, so a game object, a mono behavior, a script, an animator, a sound, inherits from object. So a mono behavior is a behavior, and the behavior is a component, I think, and a component is an object, right? So it goes like this, a hierarchy of types of things. And you can do game object, basically. So we log a message and we give it the context for this game object. And you'll see why. You'll see why we are doing that. Let's also add it here because it doesn't cost us anything. Okay. Because now when we will click on the object, it will actually, on a message, it will actually highlight our objects, right? So let's go again over it. I mean, this is like one of the most important things, like the life cycle of scripts. So awake, when you press it, you see, because we gave it the context, then this object is highlighted here. When we press and you have to press something else, then again itself. So awake was called for this object, then on enable for this object, then awake for that object, on enable for that object, then this doesn't matter now. Start was called again for this object. So you could assume that it will keep the order, and that object. But it could have went. I mean, if it could have called them like this. So awake of this object, okay, then awake of that object, whatever, and then start could have been called for this object. So you shouldn't rely on that order necessarily, right? You should rely on this thing, which is always true. Like all awakes are called before all starts. That's true. Okay, let's disable an object. I mean, let's even do it like A and B, right? Let's disable A. And I'm doing it with Option, Shift, and A, or Alt, Shift, and A on Windows. That's like a very useful shortcut instead of doing it here. So A now starts disabled. So let's see what happens. B is awake, it's called. B is on enable, it's called. Start is called B. So because it's disabled, the game object is disabled, nothing is called for A, right? And now when I enable A, it's awake, enable, start is called. So it's as if the object wasn't even there, and I'm instantiating it now, right? Or creating it, right? From code. And let's actually just enable the game object, but start with the script disabled. And believe me, I don't even know what will happen because there are so many combinations that I just, when I need to know, I'm just Googling it or now just asking ChatGPT, you know. Yeah. But I think what will happen, awake will be called and on enable and start will not be called. I'm pretty sure that will happen. So you have awake called for B, then on enable for B, then awake called for A, and then start called for B. So yeah, like I said, so for A, only awake was called. So it kind of makes sense because it's like the game object was awoken, if that's, yeah, that's the past tense for that verb. Yeah, but the script was not enabled and not and nor started, right? And this is one of the most important things to know about like programming in Unity. Like as a beginner, like this is the fundamental concept, the order in which scripts are starting and so on and so forth. Good. So we went through awake, on enable, start, and yeah, now you kind of got the building blocks. You've got the building blocks. And it's the same thing from now on. So you've got some of the first principles, and now the same thing kind of applies to other function calls. So for example, start, it's called before anyone's update globally, right? And you already know how it works with awake. It will work the same with update. So if we enable, like if we uncomment this thing, which is called once per frame, if you're new here, let's play. So we paused the game. So pause is like you're basically stopping time, right? Awake is called, on enable, awake, on enable for the other object. Then start is called for the first, start is called for the second, and then update starts to be called. And it's called for every object, and then again for every object, and then again it's not called like twice for an object and then once for another object, right? It's called in order. So first update for your first the first one, then for the other one, then again for the first one, for the other one. And imagine like we can have 1,000 objects, and this rule is never broken, right? So in theory, it's never broken unless you have like a Unity bug, which is very rare. At least very, very rare at this fundamental level, right? Yeah, and you can use this information. Like you can be sure that the update function of all of the objects will be called after the start functions of all of the objects, right? And fixed update, it's not there's not a defined moment where it's called, like before or after the update, but these three are definitely like in the same class, in the same category, right? They are like updates, the update functions, and they are more or less called once per frame. You can just assume they are called once per frame, just when you're getting started. And they are all called after start, right? I mean, let's see it just in actions to see how it works. Okay, I had to pause it because it starts. Okay, awake when enable, start, whatever. Okay, fixed update it's called for the first one, fixed update for the other one. Then update it's called for the first update, fixed update, fixed update, 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 fixed update. Yeah, it seems like it's called once per frame, but in general, you should assume that they are not really called. This is not really called once per frame. It's called. It really depends on your frame rate, right? If it's like 1 second per frame rate or something per frame or something like that, this one will probably be called still once per frame. But like in general, just assume that they will be not always be called at the same time, because this has to do with physics. So you will do all of your add force or check for collisions, or um, yeah, basically add forces to objects, check for collisions. If you want like to do some manual checking, you'll do it here, and so on. And like I basically talked about it in the previous sessions, where fixed update it's called at a fixed rate, or at least from the code's perspective. When you do time.delta time, this will never change. I mean, you can change it in code. You see it has a setter, so you can, I don't know, in start, if you want this to be like 2, you can set it here, but it sets it for the whole game, right? Not only for the script. And this fixed update is set. It's set here. Project settings time, fixed time step 0.02. So if it was 1.1 was 10 times per second, then it's 100. It's 50 times per second. This is called, right? And this is called 50 times per second, no matter your frame rate. And of course, when your frame rate is very high or very low, you need to try to simulate it that way, so that it will call this thing 50 times per second, in the sense that it will call it 50 times, and each time this thing will be 0.02. And doesn't matter like what's the reality, like your code will see, okay, you call this once and this is 0.02, then again like 50 times, and then the calculations will just work out, right? And of course, you don't do any physics yourself most of the time. You just you use a rigid body and a collider, and you decide what objects collide with what objects, and so on, right? You do that with this thing. So like you have water, and you can create a new layer. So let's see, I have add layer A, B. Let's say you can have up to 31 layers. And now you see you have A and B here, and basically at the intersection, does A collide with B? Maybe you don't want A to collide with B, but you want A to collide with A and B to collide with B, and so on and so forth, right? Um, just a very quick thing because it's easy, and yeah. So you wouldn't be doing any physics probably anytime soon. You would just be like adding forces and so on. Let's see. Hi, what do you recommend with Unity for Mac, VS Code or VS for Mac? I recommend VS for Mac. Yeah. Um, for this tutorial, I recommend VS for Mac, but I think they are trying to uh, sunset it and to use VS Code. But if you want to follow along this tutorial, you can use you should use VS, right? Because I will be talking about, especially if you're like you never used any Visual Code, nor VS nor VS Code. I recommend using VS because if I say like press whatever and that shortcut doesn't exist in VS Code, then right you cannot you'll be confused. And after that, after this course, you just try and learn VS Code or get Rider if you can afford the license. And I think you can get a free license, but I don't remember with a student discount or something like that, right? So Rider, that's what it's called. It's from JetBrains, and they do they do awesome IDs, right? Good. So that's fixed update for you. And update again. It's called once per frame. Good. Then you have on collision enter. Let's also go back here and yeah. So fixed update rigid body dot add force. Oh, okay. Let's talk about late update. So it's called after all updates. So see, it's again that pattern where a thing is guaranteed to be called after all of the all of some other methods, right? So in this case, late update, it's always called after all updates, and it's called once per frame. And it goes like this, or so update, then probably fixed update once or some more times or never, then late update, then late update, then late. So it's so update for all of the objects is called, and then late update for all of the objects. And there's more to it. I mean, you'd basically need to, because in update, most of the objects change their positions, colors, rotations, the things are created, destroyed, and so on, because that's where most of your logic will be. If you want your cameras, if you want, for example, if your player moves and you want your camera to follow your player, you'd move the player in update as usual, just in update, and but your camera should be moved in late update because the camera should see your changes that were already submitted to the game engine, and the game engine already updated the pixels on your screen so you can see them. I mean, not the pixels, but it updated the visual representation of your objects. And in the late update, only then you move your camera, which can see those changes and update the pixels on your screen, right? So just remember this, and if you remember here, it will save you probably like an hour or so at some point, because you will not see why the camera lags behind a bit, right? So yeah, camera movements should be done here, right? And the way you move a camera, and of course you will have scripts for that. There's Cinemachine, which is a very good asset, and we'll talk about it later. And camera.main.transform look at game object dot transform, or actually we can do transform directly. So transform refers to a field in this script which is in this class, because we are not seeing it, but we inherit from it, right? And then we inherit every other field or function from it. And that's what late update does, right? So you can, I mean, any change, not only position, right? This is rotation. So we are getting the transform of the main camera. So basically, this is how we access the actual instance of your camera. and we get its transform, and this is a very special and beautiful function. Look at, and it basically says what it does without any calculations on your part or stuff like that. And it says, okay, look at this transform, like at this object, right? In late update. And what it does, it rotates the camera towards that object. It basically aligns the camera's forward vector towards that position in space, right? Towards this transform. And I think you can also look at the position if you want, like, if you wanted to look at a world position, right? If you don't have like a transform, but you know maybe you wanted to look at the origin, right? Vector 3, 0, 0, 0. But instead of 0, 0, 0, you can do it like this. Not new. You don't need to write new at that point, because this 0 is uh, um, a static, a constant value here that's defined by Unity, because you need the 0 value a lot of times, and it's already here, right? It's created for you. And you also have like 1, right? Which is a vector with all of the, yeah, shorthand for 1, 1, 1. Okay, so, but let's do it like this camera. Look at this object. And I mean, you see, um, we're working with the transform component, which means that we can make also this object look at whatever, right? And what this means, again, it aligns the forward vector towards the position or the object, in this case, that you pass it. And it's this thing. So a camera, as any other object, has this thing, and the forward vector is the z vector, this one. When you do look at, it basically, let's do it here. It moves the vector in the direction of that position, so it can see it. And for a camera, that's very convenient, that because it also, like, it coincides with the functionality of actually looking at that object, right? Um, let's actually try it. So we disabled this thing because we have two scripts and we don't want to confuse the camera, right? Uh, so in late update, we say to the camera, okay, camera, look at this object, right? Oh, we have to save it. I didn't save it. And when you save it, just exit play mode and enter again. Okay. Well, let's add something to this object so we know where it is, right? In the sphere with the 0, 0, 0 position. Okay, here we are. Do we see it? We don't see it. Why we are not seeing that sphere? Maybe it's too far away from the camera. Oh, I think it's not in sight. Yeah. One second. Let's see. So this is the camera, and let's like move the object. This game object, move to view here, like in this view, like in the scene view. And yeah, it's here as well. So if you look at the camera, let's see, how should I do this? I think I can do it like this. Yeah. So you lock the inspector when you select an object, and this inspector will stay like this, right? So you lock it, and then you can go to our object and do it like this. And you don't see the camera moving actually, because I have to select, but you see the sphere stays, it stays in the middle because the camera is moving. I don't know, maybe I should like this go, and how should I? Oh, okay, I know how to do this. So I'll select this object, lock the inspector, so I can change its position from here, and then select the camera, and now move the position of the object. You see the camera tries to look at it, right? Yeah. And that's what you'll use for the late update. Not only the cameras, but a lot of things. Maybe you want, for example, to execute, I don't know, to make a function call or maybe a network call or whatever, before you're sure that everyone has executed their updates, right? That's what you'll use late update for. Good. And yeah, we talked about on disable as well. Let's recap once again. So it's called anytime you do enabled equals false. Yeah, and by the way, I haven't didn't show this. So you can also do enabled equals false. And again, this is a property that's inherited from model behavior, from, I think, from a component, I think not from model behavior. And like model behavior inherits from behavior, and behavior inherits from component. And component has this property enabled. That's why we can access it here, right? So you can also like write it in this way if you want, like this object dot enabled equals false. So this is how you basically do this thing, right? That's how you do it at runtime. Okay. Yeah. So called when you do that, or you set this, or any parent game object of this game object is deactivated. Oh, by the way, yeah, we didn't go through this thing. So let's say you have it like this. So this object is a child of this object, right? And when you disable this object also has that on disable called, right? Um, Not like this. So if you disable or if you there's this terminology that not many people use, but by looking in the code, it makes sense. So objects are activated and deactivated, and scripts are enabled and disabled, right? Because that's what the code uh, says, right? You have set active for the game objects and enable or disable for scripts, right? And when you deactivate the object, the parent. Oh, I know what I did. I have this locked here. That's why. So when you're confused, just look at this thing if something happened, right? Good, good. So if you deactivate the game object, of course, it deactivates all of its children. And this script will have its own disable called, right? Even though, like, you see, it's enabled here, and so on. I mean, we can try it, right? Well, let's quickly clear and then disable and then, yeah, let's see. Yeah, you see, called when disable, okay, this thing here. On disable, see, was called when we deactivated the game object. And of course, the updates and everything stopped. And then we enable the parent, and again, we have on enable, see? Yeah. So, yeah, scripts can be enabled, disabled, and game objects can be activated, deactivated. Yeah, when the script is disabled, deactivated, the script doesn't receive, I'd say most events, most um, relevant events. Yeah, I said some because there are so many, and probably like 70% of them aren't called when the script is disabled. But those 70 are like the most used ones. They're not called. So there's this thing that I told you to ignore on application pause, and you will control the behavior of this thing in your settings, and it really depends on platform. And this is one of those things that are platform specific. So, for example, on Android, you will get an application pause when you switch to another application, for example, and you'll get like on application pause true with the true uh, parameter value. Let's go here. Let's disable this screaming functions on application pause. Let's see if we will get it here. And of course, it will be called for all of the scripts, right? So it will be called twice if we enable B as well. And that's why you are seeing it here on application paused false, right? So this is at the beginning. Unity is calling it for you with the semantic hey, the application resumed, right? Okay, and usually if you, let's see, yeah, so if you switch to another application on Windows, it doesn't, and I'm sure on Windows, Mac, and Linux, which Unity calls standalone, Windows, Mac, and Linux, yes, they are like in the same category, right? And then you choose here which one to build. If you want your on pause, like if you want your app to pause when you switch to another application, you deselect this thing, run in background, right? And then when you select to another application, your game just freezes, right? And then your on application pause. I mean, we can do it now. I don't know if I had to save it or not. Okay, let's switch to another application. You see, application paused true. So it called our on application pause with this thing with the value of true, right? Let's put it back here. I mean, if you're in play mode, most of the things won't be changed. Yeah, not. I know that these things would change, but I don't know why it didn't change now. I mean, the change it didn't persist. Okay, that's on application pause. And like I said, on Android, when you switch to another application, I think if you have that running background, on application pause will not be called because it works out of the box. But at some point, I think when you wait too much, on application pause will be called because Android's operating system just says, okay, we'll put this application on standby because the user is doing something more important, like going on TikTok or whatever, right? And then when you stay a lot in another application, then the OS says, okay, the user is doing something really important, right? And then it actually kills your application. Like when you'll want to resume it, it will actually restart it. It's as if you have exited the application and entered again. So you'll see again the loading screen and so on. Like it's a two-step process, and it differs from OS to OS. And for example, on iOS, probably it works a bit different. But what I know and what I remember for sure is that the moment you exit the application, or I mean, the moment you switch to another application, you cannot run them in background. This on application pause, it's called automatically, and our game just freezes, just freezes. And this is a problem in some games. And yeah, this is a restriction from Apple, and you have to like categorize your game as I don't remember. You have to like there's a way to run your game in background, but you have to write that code, some custom code yourself, right? Um, And I mean, that's not a problem. Of course, you have like an idle game where you build something and it takes like a day to build, and you know, those slow paced games. Um, you don't need to actually run your game. You just you'll just see that the player enters once every, I don't know, 24 hours, and then you just see, okay, what time was when when they first exited, and what time is now, and how much it passed, and you do your calculation that way, right? um, and I mean, if we are talking about multiplayer games, um, there's multiplayer is not easy, right? Let's put it that way. um, but the way it will work in that case is you will have to do a lot of work on the server side. It also depends, like, is it a turn-based game, is it a real-time game? And because your game will pause the moment you exit on iOS, you'll have to just uh, it repose, right? But when you, let's say, go to some application, stay like 30 seconds, then go back, you have to work with your server so it can give you the latest updates, and you'll basically recover all of the lost events and so on. And there will be like a small loading. And if you've played PUBG Mobile, you would see something similar to that, where some things might happen too fast, so it's kind of fast forwards. I don't know if it works that way still, but I think PUBG is made in Unreal. I don't remember exactly. Um, yeah, and for that reason, uh, in some of my games, I've basically restricted it so that it doesn't stay in background on Android as well. So it will at least function the same in both platforms, because I already have all of the code to recover all of the state and so on and so forth. I might it just makes sense to have it the same way, to not have like differences between platforms, so that I would have half of the bugs, right? Um, yeah, and that's when on application quit is called. And I think, I don't know, is it called here? So it should be called. So when you enter the play mode, that's what it's called, play mode, and you exit, and you should get, yeah, application quitting. You see, and it's called, of course, only for enabled objects. On application quit. Good. And on destroy is the opposite of start. Yeah. So if you want to pair it with the closest one on the end of the spectrum, it's the start. So you have start and you have on destroy. And this is called when the object is being removed, and you should release any resources or whatever your logic is there. Maybe you want to play a sound when an object is destroyed, right? Or play a particle system or whatever, right? And you can destroy an object. I mean, you just delete it like this. Bam. So it first calls the on disable. And yeah, by the way, you can double click this and it goes in your editor and shows you this thing, which is cool. Um, and then on destroy, right? And I mean, let's do this thing. So in on update, so you can see how you can destroy objects in code. Input dot get key down. So the moment you press the key, so if I press A and we destroy the game object, basically this game object. So the game object this script is attached to. And if this script is attached to 10 objects, all of them will be destroyed, right? Because each script will execute, they are the same, right? And of course, since this will be kept disabled, I mean, yeah, deactivated if you want to be perfectionists, this one will not be destroyed. So let's press A, and you see A disappeared, right? It's on disable was called, and then on destroy. Now, should I keep this here? No, I won't keep it. Okay, let's see what's next. On collision, enter, stay, exit. Yeah, and we only used on collision, enter. And we won't talk about these ones. You can look into it. It's just, it makes sense that you have 3 steps. You enter a collision with an object, and then stay is called each frame while the objects are colliding, and then exit when the objects are not colliding anymore. And this on collision, enter and exit is called on both objects. So if you have 2 scripts, so let's say like, yeah, let's take the generic case. So you have a script that's on an object, but then you have like another type of script. So it's not the same template of the script, right? It's not the same code, it's a different code, but they both have the on collision enter method, right? Defined. And with the moment they collide, Unity calls on collision on both of them. And here, collision.gameObject is the other game object, right? So the first object will be, this will be the second object, right? And for the other one is vice versa, right? You get the idea. And I don't know if let's see if there's anything else. Yeah, the most used one is enter, where you can apply stuff like damage or interactions and so on and so forth. Let's see if I've created a C# Unity and C# Unity editor components in my script. Let's see what do I do in components. Okay. Yeah, so we can do something like, I don't know, we can add the rigid body, so it can be Unity can add it to the physics enabled game objects, right? A collider, so Unity would know its bounds, its physical bounds. And then we can create a 2D object, or no, 3D object, a cube, which already has a collider. And you don't need to put a rigid body on all of the objects. You only need it on one object. And yeah, let's see, where's our A? Let's place it to 0, 0. Okay. Oh yeah, and our object doesn't have like a mesh renderer, like you cannot see it, but it's collidable. But let's add it like mesh renderer. So this is the property that allows you to see the object. And here in the mesh, so we'll select the cube, or I don't know, there should be something default in Unity. Where are you, man? Yeah, I don't know, like where's the cube? Yeah, anyway, let's just add it, or you know what, let's just copy this. You can copy component and then paste values, right? And then you have your mesh renderer. Okay, and where's the mesh? Oh, sorry, actually, so the mesh renderer defines the materials. So defines not the shape, but the color and bumps and shadow, if it receives shadows or not, if it's reflective and so on and so forth, right? Default. And for that, we need, in order to actually add the shape, we need a mesh filter. That's what it's called. And now we can go cube. And this is like the Unity's default component. And of course, in order to do all this, you just go 3D object and the cube, right? And you created a cube. We just did it manually. We just created an empty object, and then added all of its components, like the mesh filter, which defines the shape, and then the mesh renderer, which displays the shape with materials and lots of things. And then we added the rigid body, so Unity will use it in physics. And then we added the collider, which defines the physics shape, right? Because you can have it smaller or bigger. So that's like the shape that actually collides. Good. So this is A, and this is the cube. Where's the cube? Is there. Okay. Let's bring this here. Okay, so we have a cube, and then we have A. Oh, I think I have to not use gravity. Don't use gravity. Don't use gravity. Well, it went anyway. Don't use gravity. Okay, so it doesn't use gravity. So let's look for on collision enter. You see, collision detected. This on collision enter was called. And because this thing doesn't have a rigid body, Unity didn't know how to move it. And let's add it to rigid body. For example, the ground, right? The terrain doesn't need to have a rigid body. I think, yeah, because it doesn't really move. But if we want to move it, then let's say it doesn't use gravity, and let's say we freeze the Y position, and you'll see why. So that it won't go up and down. Okay, so it doesn't use gravity and it doesn't use gravity, so they don't go down, right? Yeah, so see, and yeah, we don't have like on collision exit and on collision stay. Otherwise, you would just see you would see collision enter, collision stay at least once, I think, and then collision exit, right? You would see them here. Yeah, and then you can play a collision sound, or you can play some sparks here, right? Because what's another thing that's cool, you have this collision contacts. Oh yeah, contacts. And this is a list of contact points. So that's a struct. That's so basically a bunch of data that defines your contact points. And let's say you just take the first contact point, and you have a lot of things here. You have like other collider, normal. Basically, I think like if your objects collide like this, I think the normal is like this. I don't remember, but point is the most simple thing to understand. So this is the point. Basically, it's so if two sphere collides, the point would be the point where they collided, and then you can, for example, instantiate a spark there, right? If you want that. Sorry. Yeah, so you can do lots of things like this. Good. On collision enter. There's this thing on trigger enter. So it's really simple. So you remember GTA Vice City, for example, right? You had that thing where you go, that pink thing where you go and you enter a mission, right? That's an on trigger enter like functionality, right? And you can do lots of cool things with that. And if you remember, we had that reverb zones when we did sounds earlier this week, if I remember, or last week, I don't remember. um, and the reverb zone is very similar to a trigger, right? Because it triggers something. And on trigger enter, in order to have that called instead of the collision, you have to go inside, I think, here and check this is trigger, right? And just remove the rigid body. So you check this is trigger, and now when you move your object A into the cube, you have on trigger enter, right? I mean, in this case, it makes sense to also talk about the exit, or at least the, you know, uh, show it here, right? Because let's say you enter the trigger and something happens, and then you exit the trigger and you undo that thing or something else happens, right? And like imagine this is a room, right? And when you enter the room, basically your health points start to it's halved or something like that, or you can reduce the speed of your player, right? For example, maybe you want to simulate water, and like this is water, and when while you get on trigger enter, you set like player speed equals player speed over 2. You're basically halving the player's speed, right? And then when it exits, you set player speed equals player speed times 2. So you double it back, right? So you can do that thing as well with a trigger. And I think you can, let's see if this is true. So I think if at least one object is trigger, but I don't think, let's see. So basically now I've made a trigger. Yeah, it actually works. Yeah, it works. Oh, I see. Yeah, I mean it works, but it's not. It doesn't make sense, right? Because why it doesn't make sense? So basically, when we enter the trigger, you see, you press, or I mean I don't know. What I mean is I don't know what this thing is. Oh, it's cube. No, actually it works. Yeah, yeah. So it's all good. So you can have, if either of these objects is marked as a trigger, then all of the scripts on these objects will receive this on trigger enter. And of course, if they are both triggers, I mean, if you can go, if you want really to go deep into it, like if they are both triggers, they're both will receive on trigger enter, and um, I think no, I think you don't even need to have both of them as a trigger. But anyway, just use it like this. You have your object is not a trigger because your object usually is like maybe a player or something like that, right? And the trigger is actually the area where you go, right? There's an area, and this is like the simplest way to use them. Good. It's pretty powerful. See, and yeah, I think that's it for uh, the life cycle events, and also yeah, I mean, I've also added them here. So you see how many things there are here. I can post them here just so you can see them. Uh, yeah, so let's see. This is a user callback, meaning that you have to define this function. Oh, okay, no. They are all like user callbacks, and these are like internal function and internal multi-threaded function. Okay, you have awake, then enable, then this is called only in editor. So only when you are in Unity here, when you basically do this reset, this is called, right? So maybe you want to assign some default values for your script when it's created, and you'll do it in reset. And also reset is also called when you add the component, right? So when you add the component, let's do this option, keep in doc. When you create first the component, it's reset, it's called, before everything else, in editor only, right? And you have to do something like, I know this is something you haven't seen probably. So this is what it's called a compiler preprocessor, and what this means is this code will only be included in the Unity editor. When you build your game, basically Unity removes this code, right? Because in your game, you cannot access editor stuff. You cannot access, for example, I don't know, um, you cannot access like these files or um, buttons here or whatever because they are not present. You have only this window, right? You have only this thing when you build your uh, exe file or whatever APK for Android and so on. And that's why the reset is only called in editor, and it's a good practice to like explicitly put it on the using that syntax so that you show the readers of your code or your future self that you know that this code only is only called in editor. Let's add it. So my script, you see, reset called in editor, and you can do like you want your property to be 3, right? You can do it here, 3 as well. Yeah, you can do it there as well. But you can do stuff like if it's on Windows, you want your default property to be something else, and if you want something, and if you're on Mac, you want the default value of your property to be something else, right? And you do it like this: if platform is OS X editor, so yeah, Mac is also called OS X, right? You want your default property to be something, right? Maybe this is a URL for a service that's available per platform. Like you have a service for Windows and a service for Mac, and you want like the URL to be different, right? When you create that component, right? And yeah, you can do stuff like this. So that's why you also have this reset. But you know that you can do stuff that's much more complex there. So you see, it retained the 0 one because we already added it, and like it doesn't change the stuff that you have already uh changed, right? Reset, and it should reset it to 3. See, if we add a new one, it will be 3, right? And then we change it, we reset, shows us 3. Yeah, actually, I will keep that one there. Yeah, components. These are components as we've already talked about. We talked about them. So track transform for UI elements, canvas renderer, image button, demo load scene. These things, if maybe you remember them from a few days ago, right? We've used these things, and this is like a UI element, right? That's why it has a rectangle transform. That's what they call it, right? Rectangle transform. Here, like UI image has a rectangle transform, right? Yeah, Unity has a lot of built-in and community-made components, and you can create your own. And you see, you have like audio. You can have like effects. I don't know. I didn't even use effects that much. Like you have like lens flare, line renderer. I used a lot. Particle system, projector. I think it projects a texture, like makes a light out of a texture. Trail renderer is like a line renderer. You can just experiment with them. Like I won't go too much into it now. I don't know. Yeah, let's just do like maybe a line renderer. So effect, line renderer. So this is the line. You see, you have a line. And to add more points, you'd usually create this in code, right? Let's see. I don't think I can. Can I edit it here? Oh yeah, I can edit it here. Yeah, because I pressed 5 there. I just created it 5 points. See, and this is your line renderer. Something like this. And you see, The lines are actually 2D, but they have this functionality that they face the camera. They always face the camera. You see, and you have this depth, this 3D uh, effect, right? And yeah, size. I don't know what size is about. Okay, size is like how many loop. You can have like this thing, right? So they can loop, and a lot of things here like width. I think you can make it, yeah, like this, and I think you can add the add key here so that it'll get, you see, it'll get smaller. And let's remove loop. Like it gets bigger and then smaller, right? Okay. Color and lots of things here as well. You know, you can play with it, and you can have like a start color and an end color, right? Like this. This is your line, right? And you can create it with your code and yeah. Just let's go back. Yeah, so components for sound, for physics, scripts, UI, etc. We talked about all of them, right? Yeah, so let's look them from a coder's perspective. Let's go into this w2d4 components, right? Let me just quickly do something here. Very fast. Yeah, because we are in day 4, right? Good. So we are done with this scene. Discard changes. Discard changes. Select scene asset. So it's here, C sharp Unity. Okay, then C sharp Unity components, right? Oh, actually it's here, right? Good. So let's look into this thing. Let's see if there are any questions. No questions so far. Uh, let's get some hydration, right? I mean, I have some mild white tea, but water is better. By the way, I drink lots of water. Um, yeah, so we have this component. I called it W2. W2d4 components. I don't know, is it too... Oh, not even this thing works? Man, so VS Code works really bad on Mac. Because I cannot make this... I cannot zoom in and zoom out. I have to go here, probably, or... Oh, I can zoom in and zoom out? Okay, I can, but it takes ages. Okay, yeah. Well, it's too big now. Okay. So we have this component and we have this serialized field, which you remember when you declare a field like this, if you put serialized field, so it's private. So by default, if you don't put public in front of it, it's private, right? And yeah, it's private. And but if you put serialized field in front of it, it's available in inspector. No, components. Let's also call it this way, just so we can know what it is. And you see it here, audio clip. So this is the class that represents an audio file. No matter if it's MP3 or whatever, it's an audio clip. Unity deals with converting it for the most part, converting it to a common class instance, audio clip class instance. So if it's there, it means you can just drag and drop a, I don't know, droplets. You can drag and drop the sound to it, right? So if you reset, so it have nothing, you just drag this thing here and bam, it works, right? And this is a file, an audio file. It's droplets.mp3, right? And you also have a rigid body here, and you don't expose this because you don't need it in inspector. And you assigned it here, right? And you can like add some force and whatever. Let's start with this thing. So the transform component is so used that's already provided by default, right? So you have transform dot position equals this position like x2, y3, and z4. So this is how you set the position of the object that this component is attached to, right? I mean, since it's a component, you can also get it via this thing, but you don't have to because you already have it, right? It's already like it's retrieved for you, right? Yeah. So with the rigid body, we get the rigid body component. So for example, in our previous example with A, or do we still have, we don't have the rigid body, right? But let's add it, like rigid body, right? This is the rigid body. You know what, let's just try something really fast. Cube. So we added a cube child for this component because the component is empty, it's not visible, but in order to see how we move the component, we added just a small cube to it, right? Because children move with their parents in this thing. Yeah, and we have this code like add force up, so we add like 5 meters of force, right? I don't remember exactly the units, but it's like kilograms or meters, I think it's called, right? So we add 5 meters of force upwards and 3 meters to the left. Let's see what happens. So it should go like something like this. Let's see. Yeah, well, we also have this we're playing this sound. Let's see, there's no mesh renderer attached, but the script, oh, okay, it doesn't matter. How should I do that? So I cannot, so because the view changes to this one, right? When I play, but I want to see it here. Let's, this is like the proper orientation. So X is to the right, Y is upwards, and Z is forward. Let's see. Yeah, I don't know exactly, but it actually, I think it worked, right? Is that what we've done? So we gave it 5 up and left 3. Well, it should have gone this way. Well, I think you have to do it like pulse, force mode impulse. And yeah, let's make it like not react to gravity. And the mass is 1, which is 1 kilogram. And let's just disable it so we can have full control over it. So or you just disable the script. So that start will be called when we want it, right? Let's see if we enable it. Oh, I think just the force was too large, right? So let's see, like 0.5 and 0.3. Oh, we have to put f from float. That's how it works in Unity. If it's a floating point number, we have to put float. And floating point means with a decimal number. And you go and watch the previous sessions, right? Okay, let's enable it now. So let's do it. Let's go like this. Let's see. Yeah, it was quite instant. Wow, it was really instant. So let's give it like 10 kilograms or 100 kilograms. So if it has 100 kilograms, it should be... No, it doesn't work. I think it's yeah, I don't remember how this works, right? An instant force using its mass, and force, continuous force using its mass. Yeah, well, we won't go into this now. I don't really remember um, these things, but that's how you add force to an object, right? It's not important to understand the details. It's important to know that you can do it, right? And if you know that, then you'll figure it out, right? Good. Let's look into this. So what are we doing here? So we are getting the audio source component. We're actually adding a component. So you see that we could get the component if we add it here, right? But we can also add components at runtime. And you see a component was added here. And what we do here is audio source.clip. We set it this audio clip that we assigned in inspector. And we prevent autoplaying it. And I mean, it wouldn't have made any difference, but yeah, just so we can have more control, we prevent autoplaying. And then we play manually. And then again, like maybe you do something like, and by the way, you can have your start to be a core routine. Just don't think too much about it. Just understand what it does, but not how it does, right? You can do... So we wait for one new, because you're basically creating a new instance of this class. So what you do here, this is the syntax: yield return new, wait for seconds, whatever. So after 1 second, you can play the thing again, right? And then after whatever seconds, you can play it again, or you can play it in another function or whatever, right? Yeah, and you can have your start be an enumerator. Yeah, that's how coroutines. Basically, this function will be transformed into a coroutine that Unity calls for you automatically, which is really nice. You cannot make a wake a coroutine or on start, I think, but you can make start on enable. I wanted to say, yeah, good. Audio source play, so you can play the audio source. What else? Yeah, if the component has a mesh renderer, you can get it. You can disable the mesh renderer, and it's pretty easy. So let's again like add a mesh renderer with the default material. And let's add the mesh as well. Mesh filter. So the cube mesh. Bam. And now we have, let's disable this one so we don't confuse them. So now we have, this is our object. And this, where's our, no, this thing. And this component will basically take the mesh renderer and disable it at runtime, right? That's what it will do. And you see, it's not visible. This is responsible for that. You can apply a force to all objects tagged player if they have rigid bodies. So you can do this thing. Like game object find game objects with tag, and you have this thing here, tag. You can set any tag that you want. You see, there's a player that's provided by Unity, or I don't know if I created. I don't worry, but I don't remember. But you can, yeah, I didn't create it. And I only created the, okay, tag test. This is a tag that I've created. Okay, let's just remove this thing. Tag test, right? And I can just tag my, or I mean, let's tag this thing. and I think they have to be enabled for you to find them. Tag test, right? And I don't know, let's disable this. And we go here, and your object will find all of the uh, objects with a certain tag, let's say, right? And then for each of them, because it returns a list, an array specifically, um, and for each of them, you can do like object try get component of type rigid body, and this is the syntax. It out var rb, and here you'll have the rigid body. You see, it's of type rigid body. And if it finds a component, this function call will return true. You see, it has bool as return value. If this is true, then you will have correct value here. And then you do rigid body dot add force. And as you saw, I don't remember how to do that, but that's how you can, for example, on a press of a button, you find all of the objects with the tag player and add a force to it, right? Good. Just let's revert. Let's see, and audio sources. Yeah, you can also do something that's not very performant, but if you have to, you have to. You do this thing, find objects of type. So what this means, it will find all of the objects in your scene that have that type. So you can find all of the objects that have a rigid body, or all of the objects that have your component, or all of the objects that have a mesh renderer. So let's say you have a lot of very complex scene. You have like a scene with a lot of objects, right? And let's say, I don't know why, you want to hide all of the objects without disabling them, without deactivating their game object. You just want to hide them, right? So you want your logic to be, your game logic to run at its fullest, the physics, you want your game to happen, people to shoot each other and so on, but you want for some reason to disable all of the objects, right? Or I don't know, just disable all of the buildings in the sense that you want to hide them visually, right? And that's what you would do here, right? And of course, this is just one example. I mean, it's not here, but you basically do mesh renderer, and then you do mesh renderer. In mesh renderers, you do mesh renderer that enabled equals false, right? And then you disable all of your meshes. But of course, you have to keep track of them, right? So you can enable them back. You have to put them in a list, right? Like so, a list of mesh renderers. Disabled mesh renderers, and you add them here. And then later you have a reference to them. So it's like you're taking notes. What did you disable, right? And later you'd go through them, right? And do it like this, right? And you can then just clear the list if you want or whatever, right? Let's undo all of those things. And here, what we are doing, we're just getting all of the sources, audio sources, and this would be like a nightmare if you have like 100 audio sources, they all play at once, right? And again, we talked about this on collision enter, but here like I have some code and some comments so we can exactly see things. So specific case, when colliding with an object, how do I know what it is? Well, first, it starts with correctly setting up the collision metrics. And we talked about that in project settings. I won't show it to you again. So that two objects will really collide. So they are, one is, I don't know, in the layer terrain, and one is in the layer ball, let's say, and the terrain, the ball can collide with the terrain, right? And then this is called for both the terrain and the ball if they have a script attached on them. And yeah, after that in code, we simply check by name or whether it has a certain component. So you can do like collision game object, which is the other object. If name is, I don't know, A or player or whatever, you basically, this is how you check what object it is. But you can also check it like this. So um, you can also like check by tag, of course. You can check it by anything because you have the game object here, and then it's your like be creative, right? It's your, you choose the way that you identify what that object is, if you need it, right? Like if you need to do something with it. And in this case, for example, we get the game object and we say, okay, does the other object that collided with us, does it have this component on it? And we do it this way: collision that game object that get component, and if component is not null, then we have the component, and then I don't know, maybe the component has some like calculate damage, whatever, uh, right, function. Oh, in this case, we basically check whether we've collided with another object that has the script on it. And just putting it even simpler, if this is like a player script, we're basically checking whether we have collided with another player, right? Yeah. And of course, like we can do this thing here. It's even better. Like this is like even more elegant. Like if this if this is true, then do whatever, and we have the component as well, right? So if it has the component, right? So it's you are writing it faster that way. Instead of 2 lines, you have 1 line. But of course, there are other like guidelines. For example, you see this line here. It's I don't know how many characters. Uh, 70 characters. Yeah. So um, some people prefer to not go over this line. But yeah, like it's not a hard. It depends on the team if you agree to that or not. Good. And that's it with the components. So we won't be diving too deep into editor code, but it's good to know about it. So we've mostly worked with gameplay code. So code that runs in at runtime, right? Inside your game, inside your game's logic. So like players colliding, physics, and so on. But there's also editor code. So stuff that happens in editor, and this is editor. For example, you want to uh, press a button here and build your project, or press a button and create 10 cubes here, but in editor. So not when you play the game, right? You want at this time. Or you want to press a button here and something to happen, right? Or there's a lot of things. Or you want like a background process that watches your of folders. So basically tooling. That's what. And there are people in, and I'm kind of like naturally I'm kind of tending towards that category as well. Where I'm like a tools developer as well, where I create tools for Unity, and I really like creating tools, right? And yeah, just making your fellow developers' life easier, right? Um, yeah, you make their life much easier by doing like automating stuff that they're doing by hand and so on and so forth. Um, yeah, let's do just that. It's just a very simple thing. So w2d4. And let's do just that. Let's go here. So we're done with this for real. And now let's go here. And I think this one. Don't save. C# Unity editor and find the build menu items. This is build menu items. Good. And this one prevents you from building your game on weekends, right? So this is like a tool, right, for your company or for your team. So it adds some custom parameters like building a specific scene instead of building those in build settings. So you learn two things. So you learn how you build your game. Let's just do it like this. So let's comment this thing here. Good. So we start with this public static class. So we put static because we won't be creating new instances of this thing, right? Because it doesn't make sense. We don't do like new whatever. Because this is like a class for only for like interfacing with Unity, and it has to be as simple as possible, right? We don't add stuff that we won't use, including these things. So we don't need these things here and so on. Yeah, and the way it works. So what do we want to do now? We want to add a button here, which is called build. It's already here because the code exists, and we want to build the Windows. The Windows platform, which is equivalent to going Command Shift B or Control Shift B and pressing build here, right? Build, then it shows you where you want to save it and so on, right? Yeah. So the way it works, you create a class like this, a static class, and then you define a static function. And static means that it's not tied to an instance of that class, but it's like there's no instance. There's a single method in the whole program, the whole game, the whole project, right? And Unity calls this, even though it's here, it's not public, it's private. Unity knows how to access it because there's a thing called reflection, which is something for another day. And the way it works, this is called an attribute. So you can have as many attributes as you want. So I don't know. This is an attribute that you won't add here normally, but it's like an attribute, right? And an attribute can have its own parameters, right? So when you put an attribute to these methods above this method, like the menu item attribute, you give it a path. So build / Windows x64, and Unity knows to create a menu item here, build Windows x64, and then if you create another method which is called or function which is called Mac, and you have to give it another name, then the function name doesn't matter. Unity only uses those things there. Build, you see I have now two things, right? When you press this thing, that code will execute, right? Okay. And let's see what it does. So the way we reference scenes, looks, so this is again 2, it has to be 2 here. The way you reference scenes in code, in editor code, you basically do it like this. So here's a way of defining a list of scenes, right? And you can have like one scene, then another scene, and so on. And you have to put like assets, then the path to your scene, and it's actually just a path to a file in your editor, and that's why you have to put like .unity. So it's the whole file. And yeah, you even have to specify the assets folder, right? So it's here, you're here in Unity, right? You have assets, whatever, and this is like your base folder. So if you do the C# thing, that's called, I think, get current directory, it will give you the full path to this to the project that contains this thing. So it will be like, I don't know, if you're on Windows, it will be C, dev, whatever you have the project, and it will give you this path. It will end with ray.unity, right? And then you'll have your assets folder and so on. And that's why we write it like this. So this is the path to our scenes. So we choose what scenes to build in our build. That's what it's called. So we choose them here, and then we create this struct. It's a struct, so it's like a class, right? But it's a value type. Build player options, and we set the minimum is the scenes that we want to build and location path name. So for example, in the folder builds and mygame.exe, that's what I want to call it. And the target is build target.standalone Windows 64. And you see how many you have here. You have Android, iOS, and some of them will not work. If you're on Windows, for example, iOS you would not be able to build it unless you export only the project, because there are two steps. You first build the Xcode project, it's exported to Xcode, and Xcode builds the project. And for Mac, I think it works the same. PS4, a lot of other things. Switch, Wii U, Xbox, BlackBerry. um, yeah, standalone Windows 64. Good. Then this is the line that actually builds, and what it does. So you give it the build options, and it builds it, and then you just wait, and it stops the whole execution here, right? And after it builds, like, I don't know, it can take hours if your game is like very complex AAA game. And then you see this build log that report that result, because it gives you a report, and then you just decide what you want to display there, right? And there's also this editor utility that I've discovered, and it will open the folder where you have built your executable. So editor utility dot reveal in Finder, build player options, that location path name, and it actually takes it from. Oh, okay, it takes it from here, right? It's as if you would do this, but of course we shouldn't repeat ourselves, right? Yeah, and that's what it does. And let's do it. Let's do it. You see, and it started. It compiles our mono project, so it uses the mono backend, not the IL to CPP. So it should do it pretty fast. Bam, and we have this in our project. We have our build, right? So this is our project folder, then build. So it created the build folder, and it created the whole, like, this is the whole directory of the game, right? And I mean, I cannot, yeah, I cannot play the game because I'm on Mac. Will I be able to build the Mac one? I don't know. Let's try. No, 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 no. I don't want to do that. I won't try too hard, but I'm gonna hit this assembly browser, but it doesn't allow me to see stuff. Yeah, sometimes Visual Studio hates us. Let's just go here, and where are you? Custom build menu items. And oh, so it oh, now it works. Faster to change the font size. Standalone OXX universal. Oh, okay. And executables on Unix, which Mac and Linux are part of, they don't have an extension. I mean, you can call them bin if you want, but no, they don't have usually an extension. Let's see. Should this be it? Would this work? I have Xcode installed, and I don't know if it hooks it automatically. I mean, that would be like a nice thing. I never built a Mac version on a Mac. I built it like using a server that did stuff automatically. I mean, it's called Windows, but bear with me. Let's see, man. Will it work? I mean, I think it builds it. I think it builds it, but I don't know if I will be able to run it. Maybe I have to build it with Xcode. Oh, okay, yeah. So it works. It used Xcode. Nice scene. Yeah, this is the scene, and you can play it if we would have added stuff into the scene. So let's see how, like with the command and Q, right? And that's your game. And I think you can go like show package contents, and this is actually your game. And I think like this is a thing that Mac does, right? It like hides away the details into a simple uh, folder that looks like a single app, but it's just a folder of things here, resources and all that stuff. Good. Nice, nice. I was really surprised and pleased to see that it works. And it's the same on Windows. It's the same on Windows, just uh change the code there, right? And we've built this scene, Unity editor scene to build this thing. We've created a canvas and we added just a text, right? Nice scene. And yeah, like exactly what you can do here in the game window, you can do in the, this was not good here. You can do in your right in your standalone build, in your actual build. Good. Um, let's go back and just go back to the default. I mean, why not, right? So we have Windows, and then we have Mac, right? Oops. So good. I mean, let's also do it like this. So I mean, let's first enable this thing. No. So what we've done with this thing is similar to going here and press, let's press clean build. Yeah, it doesn't know where it is, and that's why it doesn't know what to clean. Let's remove it. And you can do build or build and run, and you basically build it and also run it. um, but let's press just build and save as my app. And it does the same thing, right? It builds it and then it opens the folder for us. You see, well, it actually built it here in the, it didn't build it here in the builds, right? But you can also do build and run. Can I do this? No, I don't think I need, I have to put it like builds and here, my app. Build and run. And it will automatically build, run it for us. And it will also work on Windows, right? This is button. I don't know why. Why is it the difference? Oh, I know, I know why. Because when you do this, here are the scenes that will actually get, uh, again, build and run. These are the scenes that will actually be built. You see, it built it faster because it already built it. Yeah, I don't know what. We should have seen some transition, I think, right? Transition next screen and stuff like that. And I don't know, there's an issue there, but we won't go into it now. Good. And what this thing does, so basically this is the reason why you like create maybe a tool for editor. So you get the current time by datetime.now, right? And this is a structure which has hour, minute, millisecond, whatever, months, year, right? So a point in time, a structure that describes everything about the current moment. And if you call it like after 1 second, it will be correct. It will have one more second in it, right? It will good. And we do like is weekend if now that day of the week is Saturday, or now day of the week is Sunday, right? And yeah. And if is weekend, then we create this thing, display dialog. This is the title. So display dialog takes 1, 2, 3, 4 parameters, and it has 3 overloads. Meaning that like, you can have the same method declared multiple times with a different with a different number of parameters or no parameters, right? And the C# runtime will know how to, or the compiler will know which one to call, by looking at, okay, how many parameters do you pass? And we get the title, the message, then what will appear on the positive button, which is like the OK button, and what will appear on the cancel button, right? The negative button. So this will be the title. It's weekend. Dear employee, we're not paying overtime in weekends. And the OK button will, like, you give the semantics because you handle the semantics yourself here. So you have OK will mean build anyway, and cancel means cancel and enjoy life, right? And this dialog, the moment you call it, it will stop the Unity and it will wait for you to select a button, right? Good. Answered. Okay, and you will get a bool um, back because there's only one possible option that you will set here that will change here. So you either answered okay or you answered cancel, right? And this will be true if you answered okay. And if you answered, like if you didn't answer build anyway, so this, like if you didn't, so this is like you negate it. If you didn't answer build anyway, you display another dialog with excellent choice. I mean, this will be both the title and the message, and the single OK button that I've changed it to yes, like you have a single button, right? And then editor application that exit, and you exit with the zero code. And like in programming, and in not only in programming, in systems, scripting and everything, code 0 means there was no error. Like there's nothing special to say, right? 0 means, okay, it exited as expected. So yeah, basically you exit Unity if it's weekend. And if it's weekend, and if they didn't answer, build anyway, right? And today is not weekend, so we have to force it, right? Let's force it. That's just so we can test it, right? So of course, if you go build Windows, it's weekend, dear employee, we're not paying overtime. You build anyway, then it starts building, right? And it will be fast, okay. And if you do cancel and enjoy life, excellent choice, and Unity exits basically. So this is editor code. So you see the distinction. This is tooling. So this is like, and there's a lot of tools. Like the bigger the team, like if you have like a company with 100 100 employees or programmers, let's say, that use Unity, you'll have a lot of tools, like a lot of tools for logging in, for sharing credentials, and all of that stuff. Yeah, and this is on Windows. And let's try something else, which is simpler, or at least yeah, it's simpler. Let's add two buttons to the inspector of any game object that has this component. W2d4 my script attached. Let's see, do we have it? And it's here. Yeah, custom editor. It's d4. Yeah. So we open this thing, and we already have it opened. And open this custom editor. And let's see, we add two buttons so that we can increment the my property number for this script, and one for creating a clone of the whole object. And basically we want this, where is it, man? Oh, okay, this cube with my script. So the cube with this script, w2d4. Remember, because we talked about it here, right? With these things, and it has a my property. And what we want like this component to have two buttons in inspector, right? And you see we don't add any buttons here because this code is runtime code, with exception of this one, right? But we should limit the amount of editor code in our script. And basically we should any editor code. So basically, because these buttons will not be in game, we don't. I mean, we won't see this in game because we don't need them. This code should lie in some other place. And basically, and by the way, a very important thing I haven't mentioned, I didn't mention, all of your editor scripts should be inside the folder that's called editor. And you can have like another folder and then have your scripts and so on, but there should be somewhere in the hierarchy, in the ancestors, right? Ancestors, you should have an editor folder. And this is what lets Unity know that, okay, these will be editor scripts. And also, like, you're using this Unity editor, but when you build your code, you don't have access to this Unity editor anymore, because there's a lot of code there, and of course it will take space in your application, but also doesn't really make sense because you don't have the whole Unity editor window inside your game. You only want your game logic, right? And where is it? Can you see it here? I think you cannot see it, right? Uh, can you see the assemblies? You cannot see them. Yeah, but basically Unity creates two assemblies. I mean, there are more assemblies, not only two, but let's keep it simple. You have like a game assembly and the editor assembly. And in Unity editor, you have access to both. And in your game at runtime, you have access only to the game one, right? And that's why you have this separation where you have to put this folder here, and all of your things that are under this folder will be Yeah, editor scripts need to be inside an editor folder. Yeah, this is just an empty file that I've created just for it, so you can see it. Yeah, and we want these buttons, right? And in order to do that, we create this thing. We create a new file, and I think we can give it any name inside the folder, editor folder, and we have to basically give it a name, a class, and inherit from this Unity editor dot editor. This is the class that we need to inherit from, and we added an attribute, which is this attribute, custom editor, and give it the parameter, the type of our script. Basically, this is how we get the type of a script. It's because custom editor, you cannot see it here, but maybe here. Like, if you can do it like this, new custom editor, it needs a type, right? And in order to pass it a type, you have to do it like type of and your script, right? And your script is this one, right? With your my property. Good. And now this is a custom editor for that one. And we're doing two things. We override this on inspector GUI, and basically this base call, this is like the normal thing for inheritance, if you remember, like we override the method and we have to call the base functionality if we don't want to override it in some way, because we don't want to override base functionality. We only want to add things to it. We don't want to change something in it, right? So this thing displays this thing, I think, and this thing, and this thing, or at least this thing, the script and the my property, right? And then we do like if GUI layout dot button, and this is the name of the button, add one. We call this function, and this is like Unity's way of creating a button. It's like you create the button, and at the same time you also check if it's clicked, right? You can also do like this and check, okay, was it clicked, right? But it's better to do it just this way, right? It's easier. So if we press this button, we call on add one clicked. If we press this button, we call on cloning clicked, right? So, and we have two functionalities. We add one, and this is very simple. And the way we do that, we like we have access to this target field from the base editor. So we have this target, but it's of type object because the base editor doesn't know what type your script will be. I mean, we give it here, but it's not like it's the naming, like the terminology is strongly typed. So it's not strongly typed; it's weakly typed, meaning that it can know what the object type is, but it doesn't know at like a compile type. It only knows it at runtime. And this is the way that you this is how you cast. It means casting. So you get this field of type object and you cast it to your MyScript type. And you're not changing your script, you're only changing the type of the variable that points to your script, right? And this type now is this w2d4. It's equivalent to this thing, right? But of course we shouldn't like repeat ourselves. We have var object, whatever, right? And this is Unity's way of registering an undo stack, which means that when we increment this property, but maybe we want to, and we should want generally to support undoing. So if your programmer for you presses Control Z, Unity knows how to undo this thing, because it records the whole state of your object. Yeah, at this point, and it says, okay, any change that will happen after this, I know that I can undo, and I will call basically the current state. I will call it add one to my property, in the sense like before add one to my property. This would be like even more specific. And let's do that. Let's just call it, right? Let's remove all those things. Or I don't know, let's keep it that way. So my script, where are you, man? Mesh renderer, cube, material. Oh, okay, we are there. This is the cube. And add one. You see, we added one. And if we go here to edit, we can undo add one to my property. And this is the title that we've created here. Add one to my property, right? And you can add one, add one, add one, right? And this thing is even cooler. What it does, it creates, let's see, does it use this property? Yeah, it creates a clone of this object, my property meters above it. So if my property is 1, it will create an object 1 meter above it. And the way we do that, again, we cast our target to our object so we can access its my property. Then we clone the object, and this is how you do it. You basically have your object, but you actually have a reference to its script. So a reference to this instance, and of course you don't want to clone the script, you want to clone the whole game object. So that's why you do script.game object. So you instantiate the game object, and this is like a mistake that I'm also doing like after more than a decade of using Unity. So yeah, just make sure that you instantiate your game objects, not your scripts or components. Let's turn on the lights as well. Yeah, so okay, we're cloning it, and what that means, it's exactly the same as if we've done this. Control C, Control V, and there's a cube overlapping it here. See, it's exactly the same thing. And then move by my property meters above the object. So we first calculate the position, and we do like object.transform.position, which is the target's position, right? Object.transform.position plus vector up times my property. So vector up is this vector, which has x0, y1, and z0, which means up 1 meter. And we multiply it by this number, which if it's 2, then it will be the vector 0, 2, 0, right? So we add to this position of our origin object, we add 2, for example, right? And then we have the position, which is a vector 3, and we assign it to the clone's transforms position. So clone that transform that position equals this position. So we moved it. And optionally, we change the name of the clone because Unity does this thing when you clone, when you instantiate a thing at runtime, it names it after its original object, like it's a prefab, let's say. So this is like a prefab, right? But it's here. So yeah, you can use an actual object as a prefab and instantiate it, right? And Unity like creates this thing, and instead of 1 here, it says like clone. And then again, if you clone this again, you'll have like clone, clone, and so on, right? And you can just change the name of a clone. Yeah, like you can change it to anything you want. Like if you do it like this, you won't have any clone in name. You'll have the same name as the object. I don't know why I did it like this. Like basically, Unity would do something like this, right? But I did it like this. I don't know why. Maybe there's a reason. Let's see. And of course, I do like register created object undo. Interesting. So when you create an object, you have to register. Oh yeah, yeah. So this is like a different, a specific case. So you don't do a record object when you create it. You have to do this special call, which is called register created object undo, and you only do it after you create the object. because otherwise it's impossible because you don't have a reference to the object, right? So after you create the object, you register like register created object undo. So you pass the object and basically the name of the action, clone object. So if you press the clone me, it creates an object, and then you control Z, it destroys the object, right? Um, and we select the clone automatically, so we can just keep cloning by clicking. And you see, let's see how that works. And yeah, this is the way you do it. This is only available in editor. You see Unity editor dot selection, right? And this is like the global, global. Okay, now we have light. This is the global class which describes selection. So selection means, so when I select this thing, selection dot active game object will reference this object, and when I select another object, it will be this. And if I select more objects, actually you have this active game object or objects. Yeah, you have a list of them. Good. And let's clone it. So we have cube with my script. Clone me. And where's the clone? Oh, clone is 4 meters above, because that's how we. Let's do it like this. Clone. Oh, again 5 meters. Wait, man. Have to press enter, or I don't know. Yeah. 1. Enter. Clone me. And what it did, we had this selected, and when you pressed clone me, and it creates an object above my object, and then it selected automatically this one object, and then we can just do this. Clone me, clone me, clone me, you see? And you can basically create an editor for your platformer or whatever. And I mean, the more creative you are, the more things you immediately see that you can do, right? So on clone me clicked, and I uncommented this because it does a lot of things, and I just wanted to show you one by one. And what this thing does now, so move the scene camera, not the game camera, to the newly created clone. So there can be multiple scene views, since you can open a number of scene views tabs like this. So you can have like this scene. So basically you now have another scene, and you can look at your object in some other way, right? From some other angle. And that's why like you have this, we're taking the first one for simplicity, right? You have again a global class that has like this static property. So you don't need an instance of this class. You just get the class directly. Scene views, and we take the first one, and I don't know why, but it has like, oh, okay, because it's an array list. I think this is a very old, like from Unity 1 or something like that, where they would use array lists, which they are not strongly typed. So you get objects here. You don't get like the scene view, and you have to cast it to scene view. Basically, this is the same thing as doing this, right? But it's more expressive, right? And this only works for reference types. So you cannot do it for numbers or structs. You can only do it for classes. So scene view is a class, and yeah, there's no struct, so you can show, yeah. So we have the first scene view, and then first scene view, look at clone position. So this is a similar thing to what the camera has, but of course the scene view is not a camera. And yeah, it has this utility, nice, convenient function. Look at clone position. And what it does, actually look at, it actually, I think it lies to you. I think it even moves the camera. It doesn't only like rotate the camera. I think it moves it with you. And now like you have the whole package, right? You can do this thing like clone me, and your camera also goes with your, right? You do it like this, and then I can do it like this, and like you see how easy it is to create like an editor for your level or whatever. I mean, of course, you would. This is like a horror here, like you see, because it adds a clone name on each object. But yeah, like you can change that easily. And yeah, you can add one to my property, and just you see, you can add one to my property, right? Clone me, then two, clone me, then add one. You can also have like this, right? Good. This is editor stuff, right? It's the only thing you'll see about editor. Oh yeah, and we can do Control Z. Control Z, you see, like edit, undo, clone object. Generally, in 90% of tutorials, people don't handle undo. So just remember using undo. Like if you, I mean, you can really break your scene in a way if like you can use undo for everything you've done so far, and then you do some change in your script, but it's not undoable. But then I don't know, move it from here from inspector, and this is undoable. And yeah, it gets really weird, right? You get like in an undefined state. I don't know. A well-deserved break. So yeah, it kind of makes sense. We can make like a 30-second or 30 seconds. Let's do like a minute break. Um, yeah, like a minute break, and I will just take a look at in my other tab how long do we still have. But I think we're it will definitely not be 6 hours like yesterday. Or will it? Okay, let's see. After break, we'll talk about Unity best practices, dependency injection, assembly definitions, and then we'll do an exercise for moving determinus. And yeah, I don't know if I will, because I already have it, and we'll just go through the code. Yeah, we'll go just through the code, and I think it will take maybe half an hour. That thing. Scriptable objects, assembly definitions, dependency injection, project structure, maybe 1 hour. Yeah, so it will take an hour and a half, or like an hour and a half. But we will have another break, I think, at some point. So if you like don't think you can stay, you can just wait for the next break. Yeah, something like that. And there's no meme for this break. I usually put a meme in breaks, but here there's none. Yeah, let's just stay for a minute. Yeah, no problem, man. This one is on a longer side as well. Yeah. Have a nice evening. See you. And by the way, I mean, I just greeted someone on Google Meets. Just if you're watching from YouTube, there's no, we're not done. Be right back. 1 minute. Here I am back. Okay, let's continue then. Good. Unity best practices. So the following could be the most valuable piece of information in this course. Uh, well, yesterday I think there was the most valuable. That was the most valuable piece of information for everyone, including non-gamers, non-game developers. But uh, even for game developers. But apart from that, this would be like the second most important one. If like game development is more important than just development in general, right? Uh, yeah, stuff you won't easily find in a game development course because um, I mean there are a lot of courses that can help you create like a racing game, like a platformer game. Like I mean, I don't want to just create something that already exists because I don't want to just I don't tell you that I don't know I'm doing it better or whatever. There's a lot of awesome courses for anything like RPGs and you know a lot of things. So like if you want a tutorial for how to create a platformer, just go and watch it. There are plenty of them and they are pretty good. But if you are equipped with everything you know in this course, you will know how to create it in a way that it will make your life incredibly easier down the line because you'll already be like you'll have armor right and you will be strong and like a big guy or a big girl right um yeah so the next slides distill all my Unity experience since 2013, and because each person's journey is unique, so is this compilation of recipes, pitfalls, and quality of life tips. Okay, so the project structure. Yeah, prefer grouping by semantics over syntactics, and what this means is try to have your folders represent features and functionalities and themes and parts of your projects that have a meaning to anyone, even non-programmers. Instead of having like, okay, a folder of textures, a folder with sounds, a folder with scripts, a folder with materials, another with animators and so on. Because I mean, it doesn't really make sense, and I learned this very late, like just maybe, I don't know, 3 or 4 years ago, something like that. Um, just try to group things. Like you, it's as if you have a room with arms, arms, these things, a room with legs, a room with heads, and that's how you have your world, right? But we want a room, in each room to have one person, or you want to have the whole thing in the same place, right? So yeah, I'm surprised by how many. Yeah, let's see what it says here. Yeah, many people get this thing wrong when teaching, but it's not their fault. They just learn it this way, and they just go into it by default. So this is like, I mean, there's a very awesome book, amazing book by Peter Thiel, Zero to One, and he just I mean, he likes this idea of being contrarian about a thing, but being right about it. Like, just think about like what thing it's right that most people don't agree with you uh, at, right? And this thing. So most tutorials will just create a folder with materials, scripts, I don't know, like I said, audio meshes, like for 3D assets from your 3D modeler and so on. But the right thing, the right way of doing it is to have your, for example, level 1 a folder, then level 2 a folder, and then in that folder you have like a folder player, and you have all of your assets of your player, including scripts. So you have like the scripts for your player, like player movement, then you have your sound for the players, then you have some textures, and of course if you get like at 50 things in a folder, then you might create, let's say, some folders, right? And you can at some point like have a folder that's called like textures, when you have like we had, remember, we had here in animation, we have player, and then we have sprites, where we have all of the sprites. But it kind of makes sense, right? Because it would have been quite messy to have them all of the sprites here, because they represent. I mean, if I would be like a teacher, I would give you a passing grade if you would have taken these things and put them here. It's fine. But it's when they represent like an unity, but I mean unity the word, not unity the, like they represent a single thing. You see, like they represent the idle animation, and these things represent the jump animation, right? You kind of want to put them here, right? Or at least, or for example, you could have two folders, a folder with idle sprites and jump sprites, right? Or sprites and have folders here, idle and jump, right? But that's good as well. But I think this is like the perfect for this, because you don't have too many, and like even if you had too many, maybe like you had uh 500, it's still like all right, because they are sprites and they are like players sprites, so it's all fine. And you see, like I didn't create like animators or prefabs or and so on. I will want to see if there's any other thing that I can show you here, but I think there's none. Yeah, there's none that show this concept, but I have screenshots here. Yeah, I have folders for logical submodules of your app, and logical, this is a term that's used for, I mean, if you don't understand why I've called it logical, so it's um logical grouping, it's like this. It's very simple. So you have, for example, your coffee machine, and logical grouping of coffee of its submodules would be, okay, there's a folder for the actual coffee machine stuff, but then there's a folder at the same level of hierarchy for the sugar adder, for there's another folder for the water source, there's another folder for cup dropper, right? And money grabber, and they both have, for example, the money grabber has some sounds, has some it has a 3D mesh that basically it's 3D visualization, some scripts and so on, right? And they are grouped in folders instead of having like folders with, okay, with scripts where you have all of the scripts, then a folder with meshes, you have all of the meshes, then folder with sounds, all the sounds and so on, right? So it's like you're being more human, right? You're being more human instead of being more like a computer. And by doing it that way, you'll navigate faster, much faster. Because if you're working with the player, you'll most probably want to know, okay, where's the sound for player, where's the mesh for player, and so on. But if you have, if you structure it like the bad way, if you're working with player, you have to always browse your folders and okay, you want like the sound. Okay, let's open all of the sounds, and you have like 50 sounds there. Then okay, I want the texture for the player. Then open the texture, you have 50 textures and so on, right? For all of your uh, all of your entities and so on. Yeah. So this is like the right way of doing it, but of course this is a big project. And like you can build the project. You have like 4 types of apps that you can build with the projects. And I mean app edit. Yeah, this is like the game editor. So it's like you're building an application that will create like levels for your game and so on and so forth. Then you have the game itself. Then you have the game dev, which is a game that gives you lots of cheat codes so you can test your game and so on. And then you have like a app quality assurance, which is like an automated uh, wrapper application. So it's a thing that has some testing code, and also it includes this thing in the sense that it builds it. So with this thing, you basically uh, automate some tests, like manual tests with pressing the buttons automatically and so on, right? So this project has 4 flavors of I mean, in Android, if you're an Android developer, if you come from there, you had flavors. That's what they called. But it's basically you can create uh, more types of applications in your project, and that's why like you logically separate them like this. So you have app editor, which has these things like we have like a base, you have a design editor, which is a actual screen or scene in your application. Then you have home, then you have launcher, which is like with a progress bar and so on. Then you have like a level editor where you edit the levels and you like move blocks and entities around and so on. And then you have some UI stuff here, which I just called UI base, just for simplicity. And app game, for example, like this is like the core functionality of the whole project, right? And in app game, you have like analytics. So there are some analytics like that are written by hand by me. Then you have like a hub, and the hub is like a chat, like having like a Discord inside the game. Then you have initialization, which is called like the first time the game starts. Then you have like launcher, which is the scene for. This is actually the first thing that's called in your in the app, in the game. Then you have lobby, where you have your when you gather with the players. Then login screen, side notifier. It's not a scene, but it's a a feature. So you have some like on Windows, the notifications that are similar to Windows, where they come from the right, right? That's the side notifier. Then you have the updater, which is a scene itself, which updates the application. And if you go further into launcher, you have sorry, you have cursor, and the cursor is a folder that represents some functionality to change the cursor. So to have it, you know, like if it's like an RPG game, you have like a sword or whatever, and this is like the code that does that. Then like each project has can have various conventions over how they do their stuff, but I basically use res and res built in for some special naming. Just don't worry about them now. But we have, for example, splash screen in launcher. So this is an animation or animator. This is animation, I think, or an animation, doesn't matter. Just something related to animation. So this is the company one, company two, then done. So these are the animations. Like you're displaying company one, then company two, the animation. Then this is the background for the sound, the soundtrack for the splash screen. Then you have like the animation for the first logo of the game, and then, or at least, I mean, the logo and like the second part of the logo. Then you have like a prefab with the music, which probably uses this music. So this is like a game object which has an audio source on it, right? Which references this audio clip. This is the logo, which is uh, this is like the logo for the first company, if I remember correctly. And this is actually the prefab, which references this logo and this animator. And it's just a prefab, and it at runtime through code I instantiate it, and I'm showing the first logo. Then when this is done, I'm instantiating this one, and it shows the second company logo, and then the game logo, and so on. And this is the animator, I think, and this is like the animation. Not I think, I'm sure. This is the animations, and this is the animator, and this is splash screen manager. So this is basically the brain of the whole splash screen, and this is the prefab of the splash screen. And yeah, this is the script that defines the logic for it, and this is a thing that's from state machine behavior. This is a thing that's from the animator, where you can do some more complicated stuff if you want. Yeah, and this is my splash screen. Uh, Good. And there's also a assembly definitions, ASM defs, and what they do is, but we cannot see them in from a Mac. You can only see it on Windows. You see these things. So if you're a C# developer, if you were a C# developer before, you know what these things are. So this is the solution. So it's like the whole folder of your project. But these things are projects. That's what they call it in C#. These are projects of your solution, because the solution is that's their terminology. So it's like a solution for a client. Like they have a problem, you create the solution, right? And the projects are different subdivisions of your solution. Yeah, and you have like base, design, launcher. It's those things that we talked about, right? And the way you create these projects, and by default you have one that's called assembly, C sharp, whatever, first pass, and there's something that Unity creates them, and Unity creates those for scripts that you create like this, like chaotically, let's say, right here at the root of the folder. And yeah, basically, if you have them like this, Unity creates something, but I cannot see it here. I have to show you a screenshot. Let's see, do we have them here somewhere? Open image in new tab. Yeah. So you have this assembly C sharp and assembly C sharp editor. These are things that Unity creates for you, right? But I cannot see it on Mac. It's not visible. Um, but the way, in order to just not have that, and it's good if you don't have that. I mean, if you are doing very small prototype, whatever, you can just throw all your scripts here. Don't worry. So the bigger your project will be, the more you will try to have it more structured. And this is the assembly definition file, and we'll talk about it a bit later, I think. And the way it works, when you create, so imagine like this folder is closed. Imagine that it is closed, right? So you have this cursor, REST built-in, splash screen, game launcher, scene entry. So this is a script that it's executed when you enter the launcher scene. And actually, this arrow should have come from here. Yeah. So this assembly definition, when you create it, the way it works is it takes every script that's in the folder that it's in, and from all of the subfolders, and creates a project in your solution. And they are here. You see, like, assets, up game, launcher, cursor, and splash screen. And it only shows folders that have scripts in them, right? And we'll see later how that works. You just create it. Yeah, let me just add this. So this comment summarizes it pretty well. I'll just put it here if you want to take a look later. And another thing is very important: prefer a flatter folder hierarchy where possible. So ideal guideline: only start to create subfolders once you get an unbearable amount of files. So what's the point of having 15 folders with just 2 files in each, right? And I had this problem, so I have this problem where I tend to create more folders than needed. So just have them at the same level, and you can search for them much easier now. Yeah, and I think not this, but the other thing where you have to just you have to group by semantics and not by type. I think it comes from this, like, maybe the some OCD tendencies where you'd want to put like forks where the forks are, then knives where the knives are, and I don't know, spoons at the spoons, and then have them nicely sorted, right? But in game development, or I mean in many projects actually, just try to uh, just, as I said, group by semantics. So because you're not, when you're making a game, your mission is not to arrange your utensils in the drawer. Your imagine that you are eating the food, right, in that moment, and then you need the spoon, you need the fork, the knife, and everything, and then you need them all in the same place, right? And just imagine that analogy. I think it's a very good analogy, that you're not arranging the drawer, the stuff in your drawer, right? You're actually eating something. Um, good. Yeah, I learned this the hard way. Um, so I don't know if here, like, don't try to have like uh, like I said, it kind of overlaps with the other guideline. Um, don't try to have like player then, animations and put animations there, but you have only two animations, and then prefabs, but you have only one prefab, and so on, right? Just don't do that. Just put them here. Like, I don't know, if you have like 50 objects in a folder, then start to think, okay, if you go over 50, then start to think, okay, let's create some more folders organization, right? Oh, and I said we'd go over this, but I mean, we've already talked about this. Don't worry. You just, I think I sent you, right? Yes, it's here. So just go over it if you want. Just if you want to see how many things Unity does behind the scenes, right? But how did I? Interesting. Okay, because I uh like this. Yeah, so we talked about dependency injection. So who needs dependency injection? Everyone, but who needs a dependency injection framework, like a plugin, so you can add to your project and learn? Most probably answer, not you. And unless you're creating a very complex project or not, I mean, let's say like from medium complexity to higher complexity, that's where you would need probably a dependency injection framework, especially if you don't know one. So because there's also overhead for learning it. Um, yeah. By default, Unity is based on a DI-like pattern, so dependency injection-like pattern that's called a service locator pattern. So it's not really injecting, but I mean, injecting means that somebody else adds, gives you the dependencies. Um, for example, for the coffee machine, you remember we had the coffee machine which took three dependencies, and it didn't know who gave it those dependencies, right? And yeah, so that's not the service locator pattern. That's the dependency injection, right? Poor man's dependency injection. That's what it's called. But the service locator pattern is what Unity uses, and it's this thing, the get component, right? So it's you are getting things, right? And for example, in the script, the script, so the script is attached to a game object, and that game object has more components, and this component that you are in, that you've created, here you want to get the rigid body, get the I don't know, the mesh renderer, the transform, and so on, and you get it like this, right? And this is the service locator pattern. Um, so if you're doing this in start awake only, it's like dependency injection in the sense that you don't care where those components come from. I mean, they're on the game object, so you know where they come from, but you don't know who put them there or whatever, right? It's not dependency injection per se, but kind of an alternative. Um, yeah, but I mean, if you want some things that are not attached to your game object, of course, you would need like a proxy for that. You need to uh, in the current scripts, you want to declare a field like public game object, the other object, whatever where the components that you're looking for lie, right? And you then uh, write that other object dot get component reach body and whatever, right? And these are popular dependency injection frameworks. So Zenject was basically ZE, so ZEN, yeah, Zenject was a framework, but I don't know. The guys sued the author, and the author had to create Xtenject. But it's basically the same thing. So this is one. This is the one that you had to use. Have to use. And yeah, here you will basically understand how PC injection works. So the theory, what follows is general. Yeah, I will send you this link so you can see it. So you see, you have a class and you have a constructor, and in the constructor you initialize a dependency. So your coffee machine says like new money grabber and new sugar adder, new whatever, right? And has them there, and like do coffee, right? I need to do like money grabber dot grab money, um, water source dot pour water, and so on, right? But this class now has also the responsibility of creating its dependencies. You see the problem? So, I mean, it is a problem if you remember what we talked before. But let's say like you do it like this. So this is how we've done the coffee machine, right? We pass the dependencies on the constructor. And this is better because now you don't care where it comes from, and you don't even care about the implementation. You see, you have an interface. This is how you the convention for writing interfaces I some service, right? While here you have an I some service, but here you need to create it, right? But an interface is not a class. It doesn't describe what it does. It only describes what it has, right? So you basically have a hard dependency here on this class, right? So you are initializing it to a concrete class here, and it's not good. It's called coupling. Um, this is better, but yeah, yeah, you can talk about you can read about it. Yeah, in the introduction to the inject API, um, yeah, this is what I was talking to. You see, um, instead of creating a constructor and passing the iBar, you just create a class, you add an attribute, and it already when you create new fo, it knows what to add here, and you'll see how to do that. But yeah, I'm leaving the link here. Like this is the theory part here. Poor man's dependency injection, we talked about it. Just pass the dependencies in the constructor. This is the right choice for most of you, combined with the service locator pattern. Contrary to its name, it's not bad, it's just simpler, as you don't need to import anything. It's just a convention, right? So you just pass the dependencies in the constructor. There's also Reflex, and I didn't use it, but looks promising. You can Google it. And it's pretty popular, if I remember correctly. And it was last updated last week. Yeah, 7 times faster than Zenject and so on. I think it was created after Zenject, and that's why, right? Yeah. Sorry. And there's Needle, and the philosophy is extreme simplicity, ease of use, but still being as capable as others. And it's just in a game Dragon Shift that I worked on. And actually, this is me, and I've created this one. And it's free. It's not popular, and nobody knows about it. I updated it last time. I don't know when. Like it says last year, but I don't remember exactly when. Yeah, this is the description, and I'll probably make a video about it at some point. I don't know. And this is like a gold nugget hiding in plain sight. And of course, it's free. It's everything. It's open source or not. I think it's private. Why is it private? Or I think you can download the package UPM. Yeah, I don't remember. It shouldn't be private. Is it private? Yeah. Anyway, this is the pens injection. I'll talk about it at some point. And it's very very simple, and yeah, it's simpler when I'll have time. I don't know, but it's it took like 2 months or something to create, and it basically replaces the need for Zenjek for me, and for a big game. So it's more simple. It's simpler and better, but it seems like it's not public. I don't know why. Good. Dependency injection. So again, which one should I choose as a beginner? service locator pattern and poor man's DI. So just you don't even need to know that it's called a dependency injection. You just use it as you see in tutorials. You just pass things in constructors. And yeah, assembly definitions. So an assembly definition defines a compilation unit in your project. So for example, it groups all of the scripts, all of the code in your splash screen, let's say, into a well-defined sub-project in your C# solution. Yeah, and it also helps with compilation time. So imagine you have like a million lines of code spread throughout, I don't know, 10,000 files, and you change one file, and the Unity recompiles your entire project, and that's a complete mess. Like you will wait 60 seconds for that to compile. When you create assembly definitions, and then Unity creates units of code. So it modules basically, or assemblies. They're called assemblies in C#. And basically, um, it 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 compiles only the assembly definition that the code that changes is part of, right? So let's see if I can show you something. So do we have assembly definitions here or not? I don't think I have them. Yeah, we don't use assembly definitions here. We only use them here or not here. Oh, I think there's no assembly definition that we're using, right? Yeah, it's like you create like this, create assembly definition. W2d4 dot, and this is assembly definition. This is its name, and I'm doing this thing always when like auto referenced and override references. I like to do this always, and you have to apply. Yeah, and now you see these scripts cannot see this script. Actually, this script cannot see this script. So let's create an assembly definition here. Yeah, you will do this thing when you first add assembly definitions. Let's just call it like that. And auto-referenced, override references. That's what I'm doing by default. And because this is editor, I have to uncheck this thing and deselect all and check editor so that this assembly definition. So we have an editor folder that's meant for editor only, but because you added assembly definition, now you have more control, and you have to, like, you're responsible for making sure that things don't try to be compiled when you build your game, because your game cannot access this using Unity editor module, and you'll get an error, right? Let's say could not be found. So who doesn't like this? Your editor doesn't find this thing. Oh yeah, and now if you do it like this, you have to add the reference. So you basically reference this assembly definition, right? Only that way you can access the code there. Because like if you don't have assembly definitions, everyone can access everything, and that's easier to get started, right? But now you have no errors, right? So you've created this thing, and now these are only for editor, and this thing references this assembly definition, and this assembly definitions refers to, like, contains these components here. So this code and this code. And if you would have like a folder, it would contain that folder as well. So this nicely creates a compilation unit separately. So it and under the hood, if you know what the DLLs are in C#, it basically creates a DLL. It literally creates a DLL if you're creating work. I mean, yeah, it creates a DLL, and then I think it compiles all of the DLLs into one big DLL and so on. But let's go in code. Let's see. Do you see them here? Yeah, you don't see, maybe in view. Yeah. But on Windows, you will be able, let's see, properties, toolbox, document outline. I'm pretty sure you can see them somehow, but I'm not I don't know how to use it on. Oh no, I want to see it. Okay. Yeah, and you'd basically see it here. You would see it like C# Unity, this thing. And I don't know, should use dots? Yeah, I think we are using dots, right? Here in the assembly definitions. Wait. Oh, okay. Here, where are you? Yeah, dots. You can use dots in assembly definitions. Yeah, and it will create a compilation unit. So when I change this script, it will only compile all of the scripts from this assembly, right? And that's nice. Like you have, let's say you are working on your level 2 and you have like a folder level 2 and you have everything there. And when you're working on level 2, you're most probably only changing stuff related to level 2. So it's fine to compile everything, right, from level 2. But if you have all of your scripts in one place, when you're working on level 2, you don't really want to recompile your, I know, chat pop-up or chat, yeah, pop-up, your chat functionality or your main menu buttons or whatever. You're probably like 99% sure you're most probably working on the level, on that level, right? And does it make sense to create a compilation unit for it? So first step is to group it like this, so very well, and then you create an assembly definition for that, and just try to not have too many assembly definitions. So even though like you would want to group like level 1 and level 2 and so on, if you have just like 50 scripts in your whole game, just don't create a single assembly definition, right? Or you can just not create one at all for a start. Good. Service locator. Okay, we talked about this. Assembly definition. How granular should I get? Well, let's see. Yeah, so like you have a game with different modes. For example, you have like a deathmatch mode. You have I don't know, story mode. You have multiplayer mode and so on, like training mode. You'd basically create a folder for each, and you have an assembly definition in each. And if that one grows big as well, like you start to have like 50 scripts, you can then go even more granular. So you can have your, for example, you can have another thing here, create folder, your submodule, and you can create another assembly definition here, right? And I mean, just imagine you have like 50 scripts here, because only then it would make sense to do this, right? And then what that means is this assembly definition contains everything here, still contains everything here, right? And with from all of the subfolders, but now you introduce an exception. And the exception is that this folder will not be included in this assembly definition anymore, but in this one, right? And then you, for the scripts, for example, create script. For this script, to be able to see this script, you would have to go in this module and an assembly definition. And let's do like this thing that I'm doing always. we do it like this. So the more specific, yeah, you have to, it asks you, okay, do you want to apply? Okay. The more specific thing uses the less specific thing, right? Because it makes sense. Like if you have like a base functionality, shouldn't know about the more specific functionality, right? So you kind of like the house, and here you have like the chair, and the chair needs the house in a way, right? The chair needs the house. This is the house, right? But the house doesn't need the chair. um yeah, it's an approximate analogy. Yeah, so there are modules, and this also, yeah, complies with that best practice of grouping things by semantics, not syntactics, meaning content type, but what meaning the content has, what role the content has, or I mean, yeah, you got the idea. Bad examples: enemy, dragon, player, buttons, assembly definitions. So we have like a folder for the enemy where we have a lot of enemies, a folder for dragon where we have dragon, folder for player. I don't really understand. I mean, I wrote this, but I don't remember this thing. But I know about the buttons. So you don't have like a folder where you have buttons, right? But you have like a folder with for main menu, then for chat bar, then for Christmas offer pop up. So you like detect if it's Christmas and you show a pop up to your player, and then that's inside the folder. And then you have your sounds for the pop up, any 3D objects, particle systems if you want like fireworks and so on, right? Then a citadel level, so a level from your game, or a mode of your game, which can have like maybe multiple levels. So of course you can nest these things. Like you have deathmatch mode and notification plugin. So you imported a plugin in the plugins folder, right? Because that's a good thing to do, like in plugins. And you have like this here, pixel adventure or whatever, and I think I don't think it has like scripts or anything. So if you don't need basically assembly definitions are only needed if you have scripts, right? If you don't have scripts, then it's of no use. They are only like compiling scripts. But here, for example, in the plugins, you've imported this, so it's not yours in a way. Like you didn't create it, so you put it in plugins, and you then if it doesn't have, and many assets don't have, because people don't use best practices. You'll just add yourself an assembly definition for it. Uh, Plugins dot pixel adventure, right? And that's your assembly definition, which will compile this plugin separately. And of course, it's not as if you will change it a lot, but it still helps, because Unity will try to recompile this as well each time you change something. And I think only if you change it under the plugins folder, but still it's and I think you're forced to use like the moment you start using assembly definitions, you have to start using it everywhere, because you'll get a lot of errors like, okay, this script is not saying that script, and so on and so forth. That's why I try to not use them right at the beginning. If you think that you only have like 50 scripts, just use 50 scripts, right? Yeah, like UI common, like network stuff, and network stuff can be even more specific, like database operations or whatever, right? And you have all of your code there for database operations. Yeah. Yeah, create assembly definitions for core functionality, like I had in that screenshot where app game, and there was my core functionality. Then editor extensions like tooling, like building your game, or preventing building of your game on weekends, right? In a specific separate folder, or third-party plugins separately, like I've just shown you. And yeah, that way. Yeah, keep the number of assemblies reasonable to avoid excessive compilation overhead. And I mean, in Dragon Shift, which is quite a big game, I used like 140 or something like that, but it's too much, too many. So try to keep it under 50. Yeah, there needs to be some refactory there. Um, it's not like a very bad thing, but it's easier for you to manage them. I mean, if you have like 50 scripts and 50 assembly definitions, you have like 2,500 scripts, and that's a lot. Like it's only scripts, it's not lines of code. So yeah, let's say keep it under 50, and like for very big projects, 50, right? Good. Scriptable objects. So scriptable objects are files that contain the data, and animation, for example, an animation is a scriptable object basically, but it's of type anim. Not that, I wanted revealing finder. Jump.anim is a scriptable object that contains data, and you can give it any extension that you want. And anim is a file format and basically an asset that's built in Unity. Unity creates it for you, right? But you can create this as well, right? You can create your own scriptable object. And we'll see in the Tetris game that I'll show you. Because we'll be defining the Tetris, like tetrominos, I think they are called. We'll be defining their shape in the inspector here. So basically we can create an infinite and random number, an infinite number of tetrominos, but also their shapes can be of like anything we want. And we'll do it here in inspector basically. Yeah, they are files that contain data or like references to other scriptable objects, so they can reference each other. Because you can have scriptable objects, basically files that define only a single piece, like how it looks, but then you have like a scriptable object that represents a level, and then that level might allow only some kinds of tetrominos, right? And then you have like maybe your game design, you can call it, scriptable object that contains all of your levels in which order, and you can repeat levels, and some might be locked or not, and so on and so forth, right? So they can reference each other. And look, so a scriptable object can also be seen as here, but this is a mono behavior. So it's not, I mean, behind the scenes, mono behavior is also a scriptable object, right? But this can be should be attached to a game object, while a scriptable object cannot be here, cannot be attached to an object. It only lies in your project window here, and you can instantiate them, and you will instantiate them at runtime, but you don't associate them with an object. They are kept in memory only, and we'll see them, but they work the same. Like they have some properties that you can expose here in inspector, and for example, you can drop other objects onto them and so on. Yeah, it's one of the best ways to store configuration data and attach it to various objects. Yeah, I mean, you can attach it in the sense that, for example, here you write here, right? And now your script, like you can call it settings, right? I called it obj, scriptable object, and a scriptable object can be everything. I think can even no, animation is not scriptable object. Interesting. Yeah, basically you let's see, create. Let's assume we so don't worry about how I did that. So imagine like these are some settings. You see, these are some settings for a level, and you can just drag it here, right? And here you basically cast this scriptable object to the type that you know that will be there, and basically, or actually you just declare it as Tetris level CFG. I mean, I'll show it, but basically that's what I want to show, that you can attach it in the sense that you not attach, but like because the term attached is reserved to attaching like a component here, like you attach one to the game object. But you basically like assign it to scripts fields like here, right? And then this maybe this thing defines like what gravity to use, how many levels to have, what each level has. Like maybe you have like a tower defense game and you have like waves of enemies, how many enemies, how what enemies are each wave, and so on, what groups. And you have like this is the game manager, and it uses the settings to basically create your game, right? Um, Good. And you can then swap them. Like you can have one game mode, then you can have another game mode that you swap it here, right? So it depends on what you need. Good. Yeah, like asset files like animations, texture, and prefabs behave similarly to scriptable objects, right? Because you click them and you have some properties here, right? And this is exactly how scriptable objects work. They are just like an empty a drawing board for you, and you add anything you want. They can be infinitely complex. In a Tetris game, a scriptable object can represent a type of a piece. And let's try this right down right now. Yeah, and we'll now go and we'll look into a Tetris game, but a very simple one. And like we won't be creating it. I will only show you what I have already done, and you'll get the idea. It's very cool. I don't know if it says a break, then let's do like a 30 seconds break, right? So sorry for the sound. Okay, ready? Ready. Okay, at least one meme. I should have put more this here. So I used to think correlation implied causation. Then I took a statistics class, and now I don't. Sounds like the class helped. Well, maybe. I like this nerdy meme. And this actually applies to code as well. So sounds like what I've changed worked. Well, maybe it works because of some different reason. You're just taking credit early. Yeah. So let's apply some of these principles, including the ones from yesterday, to a simple example where we move a few Tetris pieces. It'll cover just a fraction of the theory, but enough to build the mindset around it. Yeah. Tell me a story. So these are the concepts. Tell me a story, composition over inheritance, be as private as possible, separation of concerns, dependency inversion principle, where uh, objects get their dependencies from whoever manages them. So objects don't aren't stressed about where do I get my dependencies. Um, it's like food delivered at your door, right? You don't care where it comes from. I mean, you care, but um, it's easier, right? Yeah, strategy pattern, event bus, and unity specific assembly definitions. Quite a lot of them, and it's quite useful, right? I even chose them by usefulness, like what I think is useful, right? Um, tetrominos, that's what they're called, and I didn't know this until I've created this thing in this course. Um, let's create a micro game where we move and rotate these two types of pieces while following some of the best practices we've learned. So, wait a second. D4, right? D4. I don't think there's anything I had to change right here as well, right? Okay. Come on, Google, go faster. Yeah. So we'll be looking in this folder, which is at this URL. So you should have this URL. So copy link address. I'll send it here as well. I sent it already, but I don't know. Maybe you just are here for the coding only, and you are only watch the yesterday's and today's sessions, and just get there's the repo. So create an assembly definition called w2. Let's just keep it like this, right? w2d4. You can do it like this. d4, and I can do like control F, or no, it's function F. No, what's the? Wasn't it like function F for full screen? Anyway, w2d4.exs.tetris. So let's go to Unity, and this is it. This is everything here. Everything that I created. So it would have taken a lot of time if I would just uh, if I tried to go and create them by hand now. Imagine that. Would have been more useful, but we have to just do like 80-20, the 80-20 rule, right? Well, man, I have to change these things as well. Well, I won't change them. You can be perfect, right? Yeah, create an assembly definition called this, and it's here, right? This is the name, and yeah, you also can change the root namespace. And this is really cool because what this means now, if you create a script under this namespace, under this assembly definition, it already adds the namespace for you, right? You don't have to write it manually. Yeah, so we've created the assembly definition, and it's available on all platforms because it's the game, right? It has to run on all platforms. It's not like editor only or Android only or whatever. And I've done that thing, unchecked auto-referenced and check override references. Yeah, okay. Back. Yeah, set the same name in inspector. This should have the same name as the file itself. And yeah, you can have different names, but don't do that. Auto-referenced off, override reference on. Like I said, I recommend doing this each time. Helps with performance and separation of concerns. You should only enable, yeah, you should only revert them. You should only enable them when needed. So when needed means that auto-referenced means that, for example, this script, which is part of the Unity's default assembly reference that it creates, will be able to reference this assembly definition, right? So by default, Unity made it so that you will have less errors, like, right? But to have the maximum amount of performance just by default, and it's a good thing, like private by default, right? It's the same thing, kind of. So make everything not accessible. So only when this thing needs to access this thing, then you, okay, do it like auto-referenced, and this thing then can access it. Or better, just turn this thing into like a script that's inside the folder where there's an assembly definition, and then inside that assembly definition, where it will have this assembly definition references, you'll press plus, and then you'll move this one as a dependency, right? It's even better. Good, so we've created it. Now I have to go like this, right? Set the root, okay, we've done that. This will automatically add a namespace to a group, and yeah, I've already showed you that. So it all starts with the data. What data do we have? So in a Tetris game, we have more pieces, but we have only two here because for simplicity, right? We have the I and an L, right? And what properties do they have? Like they have the properties for, so the most important property is the position of each block, right? So I is made of 4 blocks and L is made of still 4 blocks, I think. So that's like the position of each block, right? And how do you display, how do you store the position of each block? Where it's just like you can have the convention like from the bottom you start from 0 0, then you have like 0 1 0 2 0 3, which means like x is 0 and y is 1 or y is 2 and so on. You know, it's like the position on the 2D system of coordinate system. So the position of each block and the pivot around which they rotate. And we won't be covering this here. So for example, I and L are easier to do because their pivot of rotation is somewhere here, like here, and for this one is here. But I mean, if you want, you can create a Tetris where the pivot of rotation is here. So when you rotate it, it will go like this thing will go here like this, right? But just keep it simple. They have a point somewhere here for rotation. And let's create a scriptable object that will hold that information for us. Like create the Tetris piece CFG script and see the ref repo. And the way you do that, you literally like just create C# script and name it like that. So it's this Tetris piece CFG, right? And the way you create a scriptable object, you do this thing. First, so you create a class, you inherit from scriptable object, right? So you have your class initially like this, right? And you create asset menu. This is an attribute, basically. Remember how we did that custom editor to display 2 buttons in inspector? It's kind of the same thing where it's an attribute which lets Unity know that we want to do something with the scriptable object. And what this does specifically, it creates a menu for us to actually create an asset of this type, right? And we say like, okay, file name is this Tetris piece CFG, and the menu name is also this. And this is a shorthand. So instead of writing this, right? We want to do it like this. We just do name of this thing. Because if you want to change this thing, it will change in some other places, right? So it's easier this way. So it's just like a nice functionality. Come on, man. I pressed. Come on, man. Escape. Okay. Yeah, and now you basically can create this asset, and you don't need to have anything here. So you can have it like this, right? And then you can create the asset. And you create it like this. So go like this, create, bam, Tetris level CFG. You see? And it's 1 because I already have one. Right? And I've just created it. And that's how they created the menus for, I don't know, creating a scene, creating a prefab, and so on, right? It's just that it's internal, you don't see it. Okay, Tetris level CFG. Let's see what the slides say. Now create a Tetris piece CFG scriptable object via menu and call it Tetris piece. Oh, sorry, I just not Tetris level, Tetris piece. Yeah, so Tetris piece. Let's go back. Basically, Tetris piece. This thing. No. Tetris piece CFG. This thing. This thing. Okay, now it's easier. Okay, you have Tetris piece CFG. So the same thing. You added uh, this attribute, and yeah, you give it this name for the file name. So this is like what the file name will be by default, and this is the how do you find the menu name, right? And you can also do it the same as with the menu items. When you remember when we've built stuff. I mean, yeah, it doesn't matter. Let's do it like this or like this. Okay, if we do it like this, then it's you'll be creating a subfolder ASD Tetris level. You see? Okay, so our Tetris level has a size. No, not this, man. Wait, how did I end up here? Tetris level CFG. Okay, so we have our Tetris piece CFG. Oh, okay, no, it's fine. We are where we need to be. Okay, again. So we create a scriptable object like I've shown you, like this, right? Create Tetris piece CFG. I mean, let's save this. Okay, we've created it, and let's see what's next. Yeah, and basically we create two pieces. They are here, right? Because yeah, like I've just renamed them, right? You can rename them. You can create as many as you want. Edit their schema. The I would be 4x4 and L would be 3x3. Oh, okay, here assumes that I've already explained what this thing does. So the Tetris piece CFG from config, right? The easiest way for me to also like explain to you, but also have something useful, was to have it like this. To 1 second. To 1 second. Yeah. So yeah, I don't know, man. You wrote something here, Louis, but I don't see you. I retracted the message. Anyway. Yeah, so this was the easiest. So basically your whole piece is your whole piece is coded in a text field, right? So it's like here. So it's a text field, right? And it's like a matrix, like a matrix. And it's a string, so it's a piece of text. And I mean, I don't think I want to do this because it would break it. Let me just create a new one, right? So I can see you, I can show you what it does by default. So if it's like this, you're basically exposing a one-line text. Here you see, and you cannot press enter, right? When you press enter, it's like you submit it, right? But if you add this attribute here, so basically you have two attributes, and of course you can have another attribute and so on and so forth, right? We won't go into that now. But this text area says, okay, it's a 4x4 text area, and I think you can have it larger, and like you can write stuff here, right? But that's the default one, like what the default text would be. And you have like the blocks scheme. So this is the thing that shows you what shape do you have, right? And here is just an algorithm, right, for going through the. I mean, it's more of a parser actually. It goes for where is it actually? Oh, here, yeah. Yeah, it goes through this text and basically it creates um, a list of lists, which that's how you represent matrices. Because a matrix, what's a matrix? It's a list of rows, right, or a list of columns. Doesn't matter the way you do it. But usually we in programming we think of in terms of lists of lines, not list of columns, right? And yeah, so you get clean scheme. So what I'm doing here is I'm taking the string and just trim, remove space from. I think it only removes space, right? Yeah, white space characters. So you can have like there are more types, many types of spaces. And then I'm also doing another sanity check here or sanity replacing here. So I'm just making sure that there are no spaces, right? But I'm allowing you to put spaces here so you can see them better, right? Um, and I mean, if you haven't already figured it out, so the Tetris piece I is defined by this thing by putting ones here, and the Tetris piece L is like this. See, like an L, right? And see, you don't have to specify all of the zeros and ones. You just specify the minimum amount of them of zeros and ones, right? You see, it's an L here, and this is also like the first how it starts if it's not rotated, right? Good. So we make this as public so that whoever has a reference to this configuration can instantiate a Tetris piece, and it gets it exactly in the format that it needs. So we are handling parsing, and we only give it the beautiful data type, like the just completely formatted, just ready to be used and instantiated, right? Okay. And I mean, here is the algorithm. It's this is more. I don't know if I should go into it. Maybe I'll go into it at the end. But generally, um, I go to the string, and you can do like get this thing splits it. So this is the new line character, and basically at the end of each line, you have a hidden new line character. And split, what split does, it gets the string and splits the lines, and it gives me a list of lines. You see, a list of strings. And now basically I have this string in the first position, then this string in a second position, and so on. And then I know the number of lines. N lines equals lines.length. Then I start creating my Boolean values. So I have like true, so 1 is true, 0 is false, right? And this is how I create like the matrix. So I create the matrix which will have n rows, right? And the number of columns. So I decide this point here, and then I go over all of the lines. So from line 0 to line n minus one, right? That's how you do a for, right? If you're like a complete beginner. And we get the line. So we store the line. So the string line, and there's this thing in C# you can do it like toChar array, and it returns a list of characters. So just one character, right? A 0 or a 1. And you then have this utility which is called convert all, and you pass it like an array, and for each character it uses like this lambda function, if you remember from yesterday, which basically here's a thing to where you describe how things should what should happen. You're basically passing it a function, right? So you're passing, okay, I convert these things, but how do I convert it? And here you describe how. So for each character, you convert this character to this expression. So C is not equal to 0. And this expression evaluates to either true or false, right? So now your entire line now changes from a string, which contains these things, to a list of, in this case, 3 values: false, true, false, right? And you store it at this position in your matrix. So basically at this row. So if I is 0, you store it, this is your first row, and you'll have like false, true, false, then false, true, false, then false, true, true. And basically that's your L shape, right? I mean, maybe there's a much easier way of doing it. Like you would just draw something, and you would then just read that from an image and turn that into bools. And but this is my take. I don't know. Yeah, and this is like the public function, right? So whoever will have a reference to this piece config will be able to get the blocks. And there's also this utility here, which gives you the blocks local positions. So like here you get the blocks in their raw format. So you basically get that matrix with true, false, false, true, false, and so on. But here you'll get the positions of the vector of, and this is like the vector to int. Remember we were using vector 2 or vector 3, which used floats. So it used uh, numbers with decimals, right? But vector integer, and you can use integers with those as well. But if you want really only integers, so that you don't have like 1.5, right? You have only integers. You can use this format, and this is like a new format since a few years ago. It's very useful because yeah, before that you had to deal with floats, right? But if you want to like exact math, like you want like 99.3 to really equal whatever it is, this is how you do it. Because with floats you'd lose some precision if you are working with a very a large amount of, like if you're working with many decimals or large numbers. Okay, and that's why I'm using an integer vector here, right? So I'm getting the blocks, and I have it like this, a list of balls. So bools, a list of rows, right? And this is how I'm iterating through it. So for each y, so for each height, so to speak, so y, it's kind of it's used for height, so that's what I'm using. So for going from row 0 to how many rows there are, so the length of this thing means that how many rows there are, right? So from 0 to 3, let's say, excluding 3, so from 0 to 2, I'm doing another 4, and now I'm going for each column, right? So from 0 to this row's length. So basically how many columns there are, and there will always be the same amount of columns, right? So from 0 to 3, I think, right, excluding 3, from 0, 1, and 2, we're checking, okay, if blocks at this row, right, and at this column, if it has a true value, right? So if block, this is how you write it. I mean, you can do it like if equals true, but only beginners do that, right? So you because it's an if needs a boolean value here, right? So if that is true, you yield return a vector for x and y, and basically you have the x and you have the y, right? And look how it works. So it works like this. So I think, so if you go like the number of lines. Let's say, so from 0, where is it? You get blocks. So you go from 0, then line 1, then line 2. One thing I have to remember. So when you split the lines, the first row is the one at the top, right? And then the next one is the one below it. Yeah, I think that's what you get. Oh, but I think I'm reversing them here, or not? No, I'm not reversing them. Yeah, but anyway, so you have the row number. So you have, okay, 0 starts here. So it goes backwards, actually. So your Y goes from top to bottom, right? It's easier that way to program. I mean, you can do something like here. I don't want to... You can do like this minus Y or something like this. I think if you want to, like, for this to have like Y is 0, 1, 2. But we have it like, Y is 0 here. Then is 1 here, and then is 2 here, right? So for this thing, basically, let's make it easier. So this function returns all of the blocks. So it doesn't return zeros, right? But not only that, like, it returns the position of all of the block. Because what's a block? A block is its own position in this case, like, in terms of what's the minimum amount of information that a block represents. Its position, right? At this point, like, you don't have like a material or whatever for a block, or a color even, right? And it will return 0, 1, so that I mean, x is first, right? It will return 1, so that x is 0 here, 1 here, and 2 here, right? As in terms of positions. So it will return 1 and 0, then 1 and 1, then 1 and 2. So because this y is 2 here, remember, it goes the other way around. So it grows downwards, right? Y is 0, y is 1, y is 2. Good. And this is again the enumerable that we've used before. If you remember, I briefly talked about it, where you can create this thing like it's as if you're creating a list that doesn't exist, or you're creating a way for the caller of this function to enumerate through a list of things before that list is created. And that list is actually never created, because the caller of this function will do this for each block in this. Do something with a block that whatever, right? And basically, it's like a list. It's like you're saying, okay, as long as this function returns me something, I'm just will keep iterating, right? And I will do something with blocks, right? That's how it works, basically. And of course, you can have like a while loop which returns things indefinitely, and it's like you have like an infinite list. But instead of an infinite list, you just create a for loop here, and you just don't have stuff in memory, right? You don't. Let's say for I 100, yield return, just an example. This is a nice example. Like it will return like first time it will return like 0, 0, then 1, 1, then 2, 2, and so on, right? And instead of creating a list and allocating memory for that list, or let's say like you have 100,000. And by the way, you can put an underscore whenever you want. It's like putting the comma or the dot, right? And it's like you can put many of these things, right? It doesn't matter. So it's easier to see. So 100,000, and instead of having 100,000, like creating a list of 100,000 things, you just make a for loop and just count to 100,000 and return a thing like this, right? Good. And yeah, this thing, we'll use this thing later. So it's basically, it returns a list of all of the position of your blocks, right? So for the L, it will return 4 blocks, right? I think I said, I only said, described 3 of them. So that like 1, 0, and so on, then 1, 2, and then 2, 2. Yeah. So X is 2 here, and also Y is 2 here, right? So that's like what it will return for L in that case. Okay, so this is like the most important thing. That's why I talked about it a bit more. Let's see what else. Yeah, you can look at this thing if you want to create a Tetris. Google Meets just ended my meet because people there are nobody else in Google Meets, but yeah, we have people on YouTube stream. I mean, anyway, this is a course, like it's not like I'm I have to do it, like it doesn't matter if somebody's watching or not, right? But it's good for you if you're watching it, and you can ask questions and stuff like that, right? It's also people learn better when it's live. Okay, next. Yeah, so our schemas looks like this. Let's create the Tetris level CFG scriptable object and file. So it represents stuff like the total world size, the spawn position of new pieces, the game speed, and the piece templates. So yeah, let's check this thing, which is already created. So Tetris level CFG. So this is the file, and it's paradoxically simpler in a way, but it has more stuff. So it has the size. So again, we use a vector2int, right, for the size. It has a spawn position. So we have like a size like 100 by 100, let's say. And you have a spawn position where it's, let's say, I don't know, x50, so at middle horizontally, and 70, right, height. That's our spawn position or something like that. Then gravity speed. So how many blocks per second, I think, a block should move. And it's usually 1. And the pieces themselves. So this is a list of references to the actual pieces, or to the actual design of the pieces, right? And since these things are private, we create a property for them to access them. And I didn't show you this until now, but because I only showed this thing, like, right? So basically you exposed reading it, but not setting it and modifying it, right? But if you are never like modifying it through this property, you can just do this thing, like you're just creating the getter, but it's better, like it's more readable, right? You basically say, okay, whoever wants the size and calls this property, I will return this thing. And for the things as well, like the same thing. And instead of the gravity speed, I want to be more like friendly to the callers, in the sense that I want to give them what they really want, and what you want is like seconds per gravity step. Yeah, and gravity step is this thing, like you have like a loop in your game, right? Then you have like, let's say, like once per second gravity happens, right? And you have this calculation here. So okay, how many seconds should the gravity step take, right? And it's like 1 over this gravity speed. So let's say if gravity speed is 1, it means like once per second the blocks drop, right? And if it's like 0.5, it means that it takes 2 seconds to drop the blocks, right? And so on. And I think it also said like, okay. And yeah, you basically create it like this as well. Create Tetris level CFG, and you only need 1, or I mean, you can have more levels, of course, but let's stick to 1, which is already here. And yeah, so at that time I decided like x is 20, and height is 30, and spawn position is 9. So kind of like 9 is at the middle, or I think it's exactly in the middle. If you get like, if size is 20, then your x goes from 0 to 19, because we're programmers, right? Okay. And the y for the spawn position is 29. Okay. Gravity speed is 1, so 1 second, I think, right? Or yeah, gravity speed is 1 block per second, or 1 second per step. Yeah, anyway, the higher this goes, the faster your things drop, right? And you have this a list of pieces, and they are here, and you can have like 3 if you want to have 3 of them, right? And when you add the higher number here, it basically clones the last thing here. Good. And this is your Tetris level, right? And pretty simple, right? It's just a class which holds settings about your game. Let's create the Tetris piece mono behavior that will represent the actual piece in game, right? So it's actually an empty mono behavior, but we can add stuff to it later if needed. Is it empty? Tetris piece. Well, it was empty when I created the slides. Tetris piece. Yeah, so this is actually the script which will attach to our Tetris game object, right? So when our Tetris game object will be created, let's say this one, like the Tetromino, it will add the Tetris piece object on it, right? So that we can access its position and so on and so forth, right? And well, let's see, what does it have? So it has a position, and this is the position of its pivot, right? So exactly in the same way that the cube has a pivot and the pivot is in the middle, right? The piece has also a pivot, and this is the position of it. And guess what? Now we have the local positions of all of the blocks of a Tetris piece, and this is the absolute position of it, right? The position, the discrete position in the level. So the level is 20 by 30, and all of your pieces will only be inside this space, right? So the initial position will be at 9 and 29, so x20, y29. And knowing the relative positions of the blocks, then you just add them up, right? So if a block's position is like on the row 0 and column 2, then you would add 0 to this and 2 to this, and then that's where actually you'll subtract 2, because y is grows down in the Tetris piece. You'll basically subtract to this from this thing, and the block would basically start at 9 and y27. Okay, and here we have the property position, and get basically gets the position, which is here, so that it's separate. But set see what set does? Set basically calls a function with the value. This is a keyword. So when you do position equals something, this thing is called here. And the value is that something, right? And it's nice here. So instead of writing all of this thing here, you're just calling the method and the method does the work, right? So you have the position and you have the configuration for this piece. So each piece knows its configuration and it's given to it when you instantiate it. You do that, you do instance.init with the configuration. So the creator of the pieces um, has to call init. Yeah, has to call init, and then it sets this configuration. Yeah, and it knows. And then what else can you do with it? You can move it by a delta. Like you can move your piece by to the left or to the right or downwards, and see just see how elegant it is, right? Here's the position, and you plus equal the delta. That's how you just change on a number. I don't know if I've covered this, right? If you're a complete beginner, right? If you have like int x equals 0, you can do x plus equals 1 or 2, and now x is 2, right? And that's how you do it position. And plus equals or plus, of course, applies to vectors as well. It just adds their component, like x plus x, y plus y, and so on. And that's how you move the piece. And guess what? Like you move it by, let's say, 1 on the x position, and it goes, because you're setting a new position, it goes to here, and this thing takes care of it. And I don't know, do we use this? Yeah, it's used. Let's not talk about this at this point, but update position does, let's say, it updates the transform position. So this is a trick here. So we're basically using the same, so our discrete space, that's what's called the discrete space, 20 by 30, can beautifully just by default map to unity space, because we are using meters, right? So basically each tetromino's block has a meter, right? So it's pretty big. I mean, it's bigger than you would imagine, right? But when you see it, I mean, you'll see it. It will be like this, right? And that's cool, right? So the position, and yeah, you can do this thing, like you can assign a vector 2 to a vector 3, and it's obvious that you want to assign only x and y, and z will be 0, right? So you basically create from the integer version of the vector, you create like a floating point vector, and you add it like x from this one and y from that one. And of course, you also set the discrete position here. You keep track of it, right? Because you will lose it otherwise, because you have it here, but you have it in floating point format. And sometimes like 3 or 4 might actually be like 3.00001 or something like that. That's how computers work, right? I don't know if it's exactly uh, if in this case it works exactly like this, but um, just assume that it works like that, right? So because floating points are made so that you will multiply and divide them and do all sorts of stuff, right? But if you want to count stuff or keep a very strict discrete space like this, right? You're using integers, right? So you are storing the position as well. Good. I mean, let's go over this as well. I mean, it's easier. So what this does is it enumerates the block's positions. So you see this thing, enumerate block local positions that we've talked before. So list that returns uh, it returns 1, 0, 1, 2, no, 1 0, 1 2, 1 1, 1 2, then 2 2, right? So 2 for x, 2 for y. It's here, so it basically returns the blocks, and we're using it here. So for each block local position, we return our own position plus that local position. So basically, our position is the absolute position in this space, right? From like in that space 20 by 30. But the blocks have are just local position. It's our local position. And if you add them up, you basically get a list of all of the world space positions of this block, of this Tetris piece, right? And guess what? Then you can use this thing and you can just instantiate the blocks using this global positions. And that's what we'll look at briefly. Let's create the script that handles input and moves the currently active piece. And yeah, from here on, it's just code. But because I've talked about that thing, let's see where it is, that thing that creates it. I think there's a factory, Tetris piece factory. So we have a factory, right? So this is a model behavior factory. And let's actually open this thing. So we have Tetris entry point, and there are multiple ways in which you can do this. But I like to call it entry point. So this is like the first thing that is executed when you play the scene. And you have the entry point, and the entry point has your level configuration, the level, and we'll talk about this later, the piece factory, the gravity input, and so on and so forth. We'll talk about this later. But the factory, where is it? The factory is a component on this entry point, right? And it needs, what does the factory need? It needs a piece prefab. So a prefab of the block itself, right? Oh no, this is the Tetris piece. So it's like the piece itself without any blocks, right? Without any blocks. It has only this script, Tetris piece, which we talked about, right? And it needs the block prefab, which guess what? It's just a block, a cube, right? And it doesn't even have a script on it, nothing, because you only want to show it. You don't need it to be any smart or whatever, right? And this is your Tetris piece factory. And what the Tetris piece factory does, so it has the configurations, and whoever uses it says, okay, Tetris piece factory creates a Tetris piece, create a Tetris piece instance using this configuration, right? This Tetris piece config. So basically one of these is either an I or an L, right? It sends it this scriptable object. And the Tetris factory says, okay, instantiate this piece prefab, which you've set here, Tetris piece. Okay, then get the Tetris piece component from it, because it has a Tetris piece component. Then we move the piece to the origin. So we move the piece to the 0 origin, because it's easier this way. So we move it basically because the Tetris piece initial position is 0. So the default value of this thing, even if you don't assign it, is 0. Because the struct cannot be null. You cannot write this. You have to write it as something. And by default, it's 0, 0. So vector has x 0 and y 0. And then we have to like accommodate. Okay, so the piece starts at 0. So let's actually move the unity part of it. So the visual part of it, let's move it to 0, right? So that they correspond. Because from now on, we will take care of the position changes, and we will make sure that, okay, we'll also, when we move it in the discrete space, like in our imaginary world where it doesn't really exist, we also automatically will move it in the Unity world. But at the beginning, we have to like, okay, it's already at 0, and we also place it at 0 visually. And we do this thing here, enumerate blocks local positions. So we are using the Tetris piece directly. I think I'm using the word positions for collision only. That's why I've created that one. So for each block position, the block is instantiated as a child of Tetris piece object, which means it's enough to move the piece and all of its blocks will move accordingly. This also goes for rotation, scale, etc. So the block would be a child of the Tetris piece, right? And the Tetris piece is at 0 position, so at the origin of the world's origin, and even like in Unity's own space. And when we add the block, we added to as a child. Yeah, as a child of this transform, as a child of a pieces transform. And this is the block prefab. We instantiate the prefab as a child with this of the piece. And now to keep things very simple, blocks transforms position, so Unity visual side is the same as the blocks position in our level side, right? Because they're both of 0, 0, but we have the block position in local space. So like, let's say like X is 1 and Y is 2, right? And it corresponds with our with the Unity side of things. So yeah, it's like this is let's say the first block is for the L is X is 1 and Y is 0 because it starts from the top. And yeah, this is the position. And good, this we basically created the blocks, right? And then we call piece.init, and init does it just stores the configuration. That's all. It stores the configuration. That's what init does. And then we return this instance of the piece, and this is like a real game object now, right? It's a real, I mean, it's a script attached to a real game object that we've created here, and that's the piece factory. That's what it does. And let's see what else. Tetris level. Okay, let's see something that's smaller maybe. Tetris input. Yeah, Tetris input. This is pretty simple. I mean, it's pretty simple in the in theory. So Tetris mover, piece mover. Yeah, let's go from this. This one is simpler. So we have something called physics, which it's very simple. So it uses an interface, and this is like using the what is it called? I don't remember that thing, but that coding pattern. But it's just using interfaces, so you don't really know how it's implemented. You're just using it, right? And what this does is it simply checks, okay, is colliding with solid world. So we can check at each position, like, I don't know, at coordinates 23 and 25, we check whether there is already a block there. Basically, that's what it does, this thing. And we create the Tetris piece mover, and since it's not a bit more behavior because we don't need anything from Unity here, we are basically pure C# here almost. And we just need, so the mover, so basically the class that has the task of moving our piece needs to know whether that piece will collide with a wall or with another piece, right? In order to know whether to whether it's allowed to move it more to the right or more to the left, right? And for that you need like somebody who knows stuff about the existing world. And what this is what that thing does. So we don't care how it's implemented, we only care that it has this thing. And see what this thing does. So it has a public try move. So whoever will, like our input class will use this thing, and we'll do like, okay, the player pressed left arrow, so try move to try move this piece, the current piece, to this direction. So x minus 1. So in case of left, you'll do like new vector 2 with x being minus 1 and y being 0, so that you're moving the x components to the left, right? And let's see what it does. So for each block position in piece.enumerate block positions, okay, new potential position, so that you have all of the absolute, so global position, so or world position, three words describe the same thing, of each block. And okay, here's where we use this thing, right? We get the global positions of all of the blocks. So basically the positions in the discrete space of our level, like 20 by 30. So a new potential position would be like the position of this block plus the delta, right? Because all of the blocks move in the same way. They don't move like one more than another, right? So, and now if this potential position, so physics dot is colliding with solid world, so we're asking it a question here, right? That's what this function it does, and that's what we're following that best practice where we are telling like a story, right? We're saying what we're doing. We're not doing like here checking if colliding. Why would you do that, right? You have a nice function and it says what it does, right? Physics that is colliding with solid world, new position. So if this block is colliding with any other existing blocks, then return false. And it's like this thing is doing two things. So it moves, but if it cannot move, it returns false. So it moves, it tries to move, and if it succeeded, it will return true, right? And I don't think we are using like the result, but it's like a nice thing to have it like this. So it's like it's doing its job, right? Um, like it knows that, okay, if it was called only move and without bool, like it, the caller of this function would assume that you can always move a piece, right? But maybe if this was in this case when it's not possible, you'd just do this return, right, and not do anything, right? You'd have to put like void you move, but it's not really perfect, right? Because you say you move it, but you don't really move it, right? And you have to say, okay, man, you told me to move it, but here I can't. I return false. And if you want, if you care about whether I succeeded or not, you have the result. I don't care if you care. I don't care if you care or not, but I did my job to basically inform you that sometimes it's not possible. Good. This is the Tetris mover. And we were in the, let's do some, okay. We were in the Tetris input here. So we have our Tetris mover, we have our current piece, which is null by default. So the default values of classes are null, or instances of classes are null, or variables of that classes actually. And then we have our input handler. And again, when we instantiate the Tetris input, we have an input handler. And yeah, actually, we'd usually have this passed here, like input, right? And we assign it, and somebody else from outside would decide how this works. But sorry, but in order to keep it simple, because like all of these patterns and stuff, they are guidelines, right? So you don't have to go at the extreme and follow them. So it's okay if your game is small and you're just getting started to do it like this, right? So it's basically we're not following that advice here of providing the dependencies here, right? We're doing it directly here for simplicity. So because we know it will never change, we'll always do it like this. If application is mobile platform, we have mobile input handler. Otherwise, standalone input handler, right? And the input handler has just two things: is left or is right. which means that are we pressing left or are we pressing right? And on mobile, I think on mobile we do like a swipe or whatever. Yeah, but I as a Tetris input class, I only care if it's left or right. I don't care if I'm on mobile or if I'm that's not my job, right? Good. And update, because we're more behavior, we have the update called by Unity. Unity is nice, and it calls update for us. Approximately 60 frames per second, but yeah, you don't need to assume that necessarily. Usually many times per second, right? And we do some checks, some sanity checks. So if the current piece is null, so it's null so it wasn't created yet. And I don't know, where do we create it? Wait, where do we create our piece? Interesting. Uh, didn't I mean, yeah, that's interesting. Current piece mover. I think I'm missing some code here, but anyway. So if the current piece is not null, or I mean, if the current piece is null, so it's I didn't initiate this initialize uh, this file, this class, or if the mover is null. So yeah, basically, if I didn't call this function, I'm just waiting until it will be called, and then I'm just checking. Okay, if input is left, then mover, then that try move the current piece to the left, and vector2.int I mean vector2int.left is the same as the vector int. Sorry, is the same as vector with for the floating point without the int left. It's just this -1 and 0, right? Just the arrow that points to the left. You have to know some math. um, and the right is to the right, right? X is 1 and y is 0. So yeah, if input is left, try move to the left, try move to the right, and at this point you might even forget how you're doing it, right? And that's the beauty of it. Like, you don't even need to be smart, right? You're okay. It's okay if you just forget how it works. You just know that, man, this is a mover and I'm trying to move a piece to the left, and I forgot how I implemented that thing, and that's fine, right? It's its job to do that thing. You're just using it. So you're not like creating a lot of calculations here and try to look smart and all of that. Like, don't do that. There's a lot of time where you would need to be smart, so just conserve that energy. um, yeah, and that's how it works. And the input handler, I don't know, it's just for example, for standalone, it's easier. You just check. So for everything that's not mobile, you check whether the left arrow is down, right? And specifically, this thing is true only a single frame. The moment you press it, then it's true. Then the next frame is not true anymore, right? That's how it works. So it's left, then it returns true, right? So, and on mobile it's a bit harder because you're basically, or depends on how you want to do it. Easiest would be to have just two buttons. I just wanted to make it a bit more complex so you can see it this way as well. Maybe you want like with a swipe, right? You want like a swipe to move your piece to the left. It's not the best user experience, but it's just for learning, right? So is left whether the delta x is smaller than a certain threshold. So screen that width. So yeah, you can get the screen width this simple, in this simpler way. So like at 10, if you move your finger by like 10% of the screen's width, then it registers as a swipe. If not, then it just ignores it. So if delta x, so if you started at a position and you moved to the left, So the delta x is a negative. It needs to be like even smaller than this thing, right? So this is like -5, and this is like -3. Then it's moving, right? And the right is the same, just the opposite direction. Like delta x, like 5, should be bigger than, I don't know, 3. And yeah, get swipe delta x, this is how it does. So input the touch count. So you have this thing which is nice. You can count the amount of touches. You can have like 5 fingers on your screen, right? So, but you only use the first one here. So if you have at least one touch on your screen, you get the first one, and you check, okay, if touch phase ended, so you press, you move, and then you lift your finger. And the moment when you lift your finger, this phase would be ended. So if touch phase is ended, we return touch dot position dot x minus touch dot row position dot x. And basically the position x is the position of the touch in screen space coordinates, but it's not a good description. This is basically the position where you pressed on the screen. And the row position is the first position of the touch contact in screen space. The first position. No, I think it's wrong. Yeah, anyway. Like this is the first position where you pressed, and this is the current position, right? So it's the same thing. If you swipe to the left, uh, if you swipe to the left, it's smaller. So think about it. So it's like 5 minus 3 equals 2. Oh, no, it's right. Yeah. So this is the current position of the touch, right? So raw position is the first. It's good. Yeah, the first position of the touch contact. So when you like you touch at x equals 5, and when you go to the left, you'll get, for example, to 3, and no, this is the thing. Like you start at 5, and then you move to the left, and like initially this is 5 and this is 5. Then when you move to the left, this stays 5, and this is 3 now. And you do like 3 minus 5 equals 2, and you get like -2, right? So you moved by -2. Okay, now you got the touch handler as well. Okay, what else? So we went through the Tetris piece mover, Tetris piece, Tetris physics, and that's the beauty of it. You don't need to understand the whole game. You have to only understand the individual pieces, the individual classes, and what class needs what other class, right? And let's see, what else? We went through this, we went through this, we went through this. Oh man, so many things here. Okay, what else do we have here? Let's see. This is simple. So you have a class which holds the current active piece. That's its own job. It's like a holder, right? It's very, very easy to understand. The physics, we talked about it. Okay, it's just for checking whether it's colliding with not or not something. Tetris active, and the active piece holder is literally just a class. So a class that implements this interface, and it exposes the piece property. And you might think that it's redundant, but I just wanted to just show you how it's done, like how to, like repetition is good, right? How to use interfaces. That is gravity. Well, let's look at the signal bus. But the signal bus, like I actually just I showed you how it works yesterday. So yeah, just look at it from there. And also here we have unsubscribe, right? So, but again, the way it works, like you have events, which can be anything. So they can be Yeah, it's a bit different here, but don't worry, it's kind of the same thing. An event can be anything. So an event can be a class, basically. You have that class. When you instantiate that class, you basically like create the event, and then you access this signal bus, and you say, okay, signal bus dot instance dot publish, and you publish that instance, and that's all you have to do, right? And whoever subscribes to that event responds to it. Like have whoever subscribes to that event has their subscriber function called, right? So for example here, on piece reached ground, Tetris level uh, receives this, yeah, Tetris level subscribes to this event. Tetris piece reached ground event. So somebody wants to know when the Tetris piece reached the ground, right? And this is the event. Basically, it's the data that describes the event. So and you have the piece. You have nothing else, right? And the signal bus subscribe to this event and call this function when that event fires, right? And then when that event fires, we have this solidified pieces holder and solidify. You solidify the piece. Basically, you turn it into the world, right? And then spawn next piece. We will talk about this. This is like the mechanics, right? Basically, it's the nicest thing about the game. Um, okay, yeah, and this is the signal bus. So you have the gravity, and this is also a mono behavior, so that we'd have this gravity loop. And the way it works, we don't use the update method here, but we're kind of simulating the update method, but we choose how many seconds to pass between each frame, right? With this thing here. So the way we're doing it, so let's see first, the gravity needs the signal bus because it uses it to publish the event that the Tetris piece reached the ground, right? We have the level, so the Tetris gravity needs to know the bounds of the level, how big the level is, and so on. Then the piece holder, so that it knows where to take the piece and move it. And the piece mover, so that it will know how to move it, right? The gravity only applies gravity and knows how much gravity to apply and so on, right? And it publishes this, like it checks whether the piece reached the ground and so on and so forth. But it doesn't know everything, right? It uses its dependencies to do its job. And yeah, it stores its dependencies here, and it starts the coroutine, the gravity loop. So that's how you start coroutines in Unity. You basically start coroutine, and you actually call the function because it will first return something. But just you can even memorize it. I memorized this for many years until I understood it. So yeah, start coroutine, and you call it like this, and this thing starts enumerating and executing, right? And it um, first executes this. So delay, wait for seconds, level seconds per gravity step. Remember, we have this thing. So basically, after how many once how many seconds is the gravity applied, right? And we have it here. So we have this thing. It's an yield instruction, which is only used in coroutines. And basically, while true, so indefinitely until you destroy the gravity object, which means like destroying like the entire game, which means exiting the game, which we don't care at that point anymore. You do like yield return delay, and which means Unity will say, okay, let's wait this amount of seconds. Okay, it waits, it executes everything else in the game, and then comes back after approximately this amount of seconds. And then it does apply gravity step, right? Applies the gravity step, and then again, waits, applies gravity. And so basically you have your loop here. And apply gravity step does this thing like, okay, if active piece holder is null, return. Basically, it shouldn't really happen, right? But it does it. Because if this is null, I mean, when you call this thing, you set it here, it's not null, and you start the coroutine, and the coroutine calls this. So this is never null, but it's, I don't know, I just decided to check it there. Then we do like active piece holder piece, and we have like active piece. If active piece is null, we return. Maybe like you have like a pause after you have solidified your piece. Maybe you're waiting like a second or two, and then you spawn one. So you have your piece holder, but maybe you don't have the piece, right? And it's good to have this assumption here that, or it's actually not having an assumption. Like you don't assume that you always have a piece. You assume that maybe you won't have a piece, right? Um, and of course, you have to try to not be too defensive, right? To check everything and always just find the balance. Um, Good. Apply gravity step. And then you actually do what's is the interesting part. So mover, try move, active piece down, right? And down is this vector. 0 for x and -1 for y, right? Y is downwards. I mean, y is vertical and -1 is downwards. And you don't care how the mover works, right? You just try move active piece down. And it returns a boolean, and yeah, I am actually using it. So if it succeeded, it means I didn't reach the ground, right? So if it succeeded, it means it had space. So this is the succeeded. So if it moved it, it will return true, and then succeeded would be true. And if I want to know if it reached ground, I basically know if it didn't succeed. So reach ground is not succeeded, right? So it reached ground only if it couldn't move it, right? And then I'm checking if it reached ground, signal bus that publish this event. Tetris piece reached ground event with the active piece, right? And this is your gravity. And let's see, like we went through the level config, physics, signal bus. Yeah, let's talk about the level. So this is the level, right? And this is the, I mean, we're really close to end. This is the level, is just a component here. And the Tetris level has its own configuration. Like this is like the most obvious thing, place to have the configuration. The Tetris piece factory, it has the Tetris piece factory, right? So the level would need to know how to create new pieces. It also needs to have an access to the piece holder so that it could say, okay, create the piece or change the piece. Like when the current piece solidifies, it needs to assign it the new piece. Basically, it creates it with the factory and it assigns it to this holder. Like you say, hey, hold the piece now. This is the new piece. And then solidified pieces holder. Actually, let's look into this. I don't know how to navigate on the Mac's Visual Studio. And yeah, everything like Visual Studio Code, it's best on Mac. But yeah, just hang on there with this. Go to definition. Yeah. So the Tether solidified pieces holder is a thing that holds a list of all of the pieces, basically, that cannot move anymore. And also solidifies a piece. Basically, it adds it to this list. And let's see, Tetris solidified. So yeah, it has a list, which is this list. And you can do this trick, like you can expose it as a read-only list. So people cannot do stuff like this. Piece.0 equals whatever. The property or indexer cannot be assigned, it's read-only, right? So you can, it's a nice thing to use when you can. So, and you see that you can implicitly convert this to this, because it, I mean, It doesn't matter. You just can, right? So you have your list here of solidified pieces, and you expose it as this read-only list, right? So whoever has an instance access to an instance of this holder can only read them. And when you solidify a Tetris piece, I mean, you can have lots of things here. You can have like particle effects and lots of logic and like store it in the database or whatever. It just adds it to a list, and that's it. That's everything it does. But here we don't know what it does. We just need it there, right? We are just solidifying it here. Good, and that's its dependencies. And whoever creates our own level instance, it's giving us this example, these dependencies. And this is like poor man's dependency injection, remember? So we're giving we're getting the dependencies. We don't care where we're getting them from, which is awesome. And yeah, we are assigning them here to our own fields. Yeah, and it would feel a bit redundant. You can see now how a framework, a dependency injection framework would help you. Like you just say inject, right? Or with the needle pin. Like I really wanted to be really extremely minimalistic with that um, framework with the needle from the Fallen games, right? And I instead of inject, I have the keyword pin. Yeah, and then you won't need to have this thing, right? Like you would do it like this. This would be like this, right? You don't need to do this thing. It would be amazing. um, good, but that's just for prototypes and smaller projects. Just keep it simple, right? Yeah, and the level subscribes. So remember, we have a reference to the signal bus. The level subscribes to this event. Tetris piece reached ground. So when the current piece reaches the ground, we'll have this function called on piece reached ground, right? And we don't care about the piece here because we have the piece holder ourselves. And basically this thing will be the same thing as this thing, right? Yeah, and when the piece reaches the ground, we ask the solidified pieces holder to solidify this piece, right? And whatever that means, we don't care. Solidify it. And of course, like in our case, we don't have that. We know when the line disappears, right? So basically, when you complete a row and you give a score and so on, we don't have that. We're just keeping it simple. But this solidifier would do that, right? Good. And then we spawn the next piece, right? This thing should be like this, like one space. Spawn next piece, and next piece. Let's see. Well, how do we do it? So n pieces, config pieces count. Oh, okay, yeah. So we go to the config, Tetris config. So this thing, which has all of the pieces, like all of the configurations of the pieces here, only two in our case. So this will be 2. And we get like Unity engine random range, and it gives you a number between 0 and 2, excluding 2. And it gives you like 0 or 1. Next spawning piece index, right? And we simply just ask, okay, config give me the piece at this index, right? It will be either 0 or 1, or okay, in our case. And this is our configuration. You see it's Tetris piece config, which is one of these things, right? Which only has like a block schema in it. Okay, and then we have the piece factory, create, and we give it the config, and we don't care how it creates it. Of course, we have the factory here, and we'd usually like have an interface, and we only have like an interface here, but we I guess, as I said, we don't have to be like extremist and apply everything, perfectly, at least in smaller projects. Yeah, piece factory dot create. a piece with this config, and it gives you the piece, and we directly store it in the piece holder, right? We don't like do like var piece and then this equals piece. We just directly store it here, right? And we've created it, and then we said, okay, this piece dot position, and we're kind of doing this thing. What was it called? Inappropriate intimacy or whatever, where we do like dot dot dot. But it's alright. Like if you're doing like twice, it's fine. Like if you're doing like this and then like this, right? Don't do that. Just if you're doing that, just create a function inside this thing that does that thing, right? Right. So we are basically spawning it and then assigning it the spawn position, right? And of course, you could have done it like this, like config.spawn position. So you created and also added set this position. That would have been better. Good. Yeah. So I want to show something here, but I don't remember what. So the piece factory, we talked about the piece factory. It just compiled. That's why. Okay. And that's our level. And now let's talk about our entry point. And our entry point, we finally just discussed about all of the details. And now this is like the highest level thing that we talk about, in the sense that it's the literally like the highest as a height, in the sense that you are seeing everything like on a map, right? And our entry point has 5 dependencies. It has the level configuration, so level config with these things. It has the actual level, which is on itself. So on the same object, you have this level, which is this thing. Then you have the piece factory, which is also on this thing. So we're just keeping it simple, right? You don't need to just create many objects when you can just add a lot of components on a single object. You can add like 30, let's say, would be a good number maximum. Maybe 20, right? After which you maybe, okay, just create another game object, because they surely can be grouped in some way. Yeah, then it needs the gravity. The gravity, yeah, that's what it's called. The gravity, it's a noun, so it kind of works, yeah. Or I think like gravity physics should have been called probably. Then the input, so Tetris input, and yeah, you assign them all here. So the Tetris entry point has all of these here, and on start, because it's a model behavior, its start is called first. We create a signal bus. So yeah, you just create it like that. No, interesting. I just do I use this? Oh, I'm not even using it. So yeah, last time, and this is better, much better, because you can then test it. You don't need it like this. So because you won't be accessing it this way as a singleton, right? This is like more of an anarchistic way of accessing it, because you're creating it here, and the entry point passes the signal bus to whoever needs it. For example, gravity needs it and the level needs it, right? And we are just using um, one event, the event where the piece touches the ground, and so the gravity publishes the event and the level gets that event, right? But of course, you will have like hundreds of events in your game. The only thing is just make sure that you will not rely too much on it. Just make sure that, because just try to not base your game's logic on a signal bus, in the sense that um, you're playing a level, then you're waiting for some enemy to come close to you, and then you do show some pop-up and then whatever, and don't use events for that. Use events for stuff like, okay, the player has just died, okay, um, somebody listens for the player is that event, so that it would play a sound or show some fireworks or show you like maybe a dialogue or a model, right? Or a stuff that's a bit simpler, not core game logic that like defines the entire game, right? That can break your game if it happens in some different order. Good. So it creates the signal bus, it creates the active piece holder, it creates the Tetris solidified pieces holder, it creates the physics, and it gives it the level config because that's what it needs, and the solidified pieces holder, and also the mover, and it gives it the physics. So everyone says in its constructor what it needs. For example, the Tetris piece mover needs the physics, and it needs a class which implements this interface, and it doesn't know, it doesn't care how it's implemented, it just needs it, right? And it gives it this, you give it here, like Tetris physics. This is the actual class, right? And yeah, this is a way of implementing an interface without making the function public, because usually you do it like this. This is how you implement the interface, right? Because you will adhere to the contract. You have a function which returns bool. It has this name and has this parameter type and name, right? And but you can do it like this as well. And like now it's private. It's private in the sense that nobody else can access it unless you manually cast this class to this, or unless you access this class through this interface type. So you need is colliding with word. So you need an instance of this. Basically, you have to access it indirectly, right? Because if you do is colliding, doesn't, it is not here, right? Basically, that's how it works. And let's do it like this. Good. And this is the entry point. And yeah, that's your whole game. Um, this is your entry point. And I know, like, I should have maybe started with the end result. That would have been better. Yeah. So this is basically when you'll be working with dependency injection. This will actually be the place where you do the plumbing, right? You'll do like, okay, this thing is that thing and that thing is that thing, and you'll have like a long list of things, and you can even like um section it into various files if it grows big, uh and that's separation of concerns, right? The only purpose of this class would be to figure out dependencies between things, right? And then the things themselves will be happy, they get their dependencies and so on and so forth. And yeah, let's see how it works. The only thing that I'm not sure of is how in the world will that piece move in the level. Where is this? Where it is in the piece holder or piece physics? Where was that thing? Piece mover? No, no. Gravity? Tetris input? Oh yeah, this thing. So I don't remember, like, did I just change this by mistake? Tetris input? No. This is like command L. So we have current piece, we have mover, we have input. We initialize it. Input handler, standalone input handler. Hmm. Oh, I think I just maybe didn't press save at some point, and but let's see, let's see. So we're here, and yeah, basically we don't have any object here because we are creating them at runtime. Let's see, will it work? Like, yeah, because we're not moving it. Interesting. Let's move it. Let's move it. Basically here. So we should initialize our Tetris input. Oh, and actually we don't need like the current piece. Okay, now I get it. We don't need the current piece. We need the so the entry point should give the input the active piece holder. No. Okay, then it doesn't have like a current piece. And I mean, let's not check for this because it's redundant. I mean, actually, let's check for the piece only. Because like I said, maybe at some frames you don't have like a piece. I don't know. You don't you wait until you spawn it or something like that. Yeah, so this is the input. So in update, if the piece is null, we just return. Return means like cut it short. So don't execute what's below. Um yeah, this is it. And there was something about the gravity. So the gravity basically didn't apply. But let's do it like step. So yeah, we've theoretically fixed a part here, but also we want to see, okay, how is the gravity applied? Step, step, step. Okay, so it works. Good. But step, step, step. Apply gravity step. And let's do some debugging. What a great thing. So basically you have to be an optimist, right? So it doesn't work, so you're lucky and we'll do some debugging. So yeah, you press debug and yeah, on Windows, it's the same thing. You have a play button there, or actually like a bug, a literal bug icon. Okay, so we put a breakpoint here. I even didn't tell you about it. Like you can put it like them like this, right? And I think it's F8 or no F10, right? Is it F10? So where is it? Debug. Step over. Oh my God, what are these things? F10. Okay, F10. Good. Um. So active piece holder is not null. Active piece is not null. Try move. F11. Oops, F11 doesn't work. Step into. Oh man, do I really have to use these weird shortcuts? So it's Shift, Command, and I. So this is like, man, can't believe it. Okay, step into F10. So you have like 10 and 28. Oh, I know what happens. It collides. It collides because our position is 10 and 28, and I think it collides with the ceiling, basically. Yeah, I think it collides with the ceiling. So what that means, I think like I had some changes on some other PC that I haven't pushed. But if we are lucky, it will be fixed by just this thing here. Tetris level, where are you? Level config and spawn position, like 26. Come on, man, what's this here? Just to be sure, I put it 26. Or, yeah, let's put it 26. Yeah, that's your piece. And you can move it, right? And it basically, let's scale it. Yeah, that was the problem. Like it was colliding with the ceiling. Yeah, and it goes to the floor. Yeah, and I mean we can't even force it, right? But let's see, can we do it like this? No, I think it's already made up its mind. Yeah, and it solidifies it, and then you can move another one, and so on and so forth. And that's how it works. Let's make it like 4. Does it skip? I don't know. It just goes faster. Yeah, 15. Yeah, and of course you can have you can have rotator script that rotates them, right? Whoever played a lot of Tetris, maybe they have some uh you know, have some memories. Like, yeah, this is it, right? And of course there's no optimization. Like you have all of these pieces here. Their Tetris piece script is here. Their update is, I mean, they don't have like an update, but function which Unity would call. Like if you would have like an update here, Unity would call this thing, right? And if you have like 100 pieces, Unity would call it for all of 100 pieces, and it's not an efficient way, right? You would like the moment you solidify them, you should like extract the Tetris piece script and delete it and so on and so forth, right? So yeah, we've done some debugging as well. But yeah, just the shortcuts are horrible on Mac, so probably on Rider they are better, and on Visual Studio Code they are better. But on Windows, like Visual Studio, the simple version is still like the best, or the best. I mean, it's the simpler one, and it's free, and it's just good enough for medium projects. Um, yeah, and it has this shortcuts like F10, F9, F11, and you can just jump through the lines and so on and so forth. So yeah, congratulations, whoever stayed until now. Um, I hope this session which will help a lot of people that want to start their like gaming career, or just get better if they have already started it. Um, just try to use ChatGPT a lot, or Gemini, or Claude, or whatever you use to just ask it a lot of questions. I know it kind of seems off topic, but LLMs will never be off topic. um, just anything that you just don't understand, or the, things that I didn't talk about, because there are many of them, and many of them are even basic and I should have talked about them, but there was no time. Just go and ask an LLM, and it will give a very good explanation, and an LFI and LE5 and everything, right? Because Unity is very popular, C# is very popular, so it has all of that knowledge in its training data. Um, yeah, and I think let's see if we have any surprises here, or yeah, there's a reading list folder in the support repo, and you'll find some of my recommendation if you want to like dive deeper what makes a great game programmer. And they're not mandatory, but you should prioritize building. Yeah, so if you have to choose whether you build stuff or read stuff, just build stuff, build stuff, and then when you read about it at some point, if you find out something really really important, um you just I mean something that just teaches you a new way of doing something, and or an easier way, and you just immediately memorize it, because you say, man, I didn't know you can do it that easily. I spent so many hours, it's amazing. And that's a more joyful way of reading about your stuff, right? Instead of reading and say, okay, maybe I'll need this, I don't know, um, and then building, right? Just prioritize building. But if you want to read first, and I would recommend you to just take a look at some resources. Um, resources. You should. Where is it? Come on, man. In the repo, it's here. Read me. Yeah, just read this thing. Lots of things. Yeah, here. How what you should look at, where should you dive more, and so on and so forth. But in the 99% of cases, when you see something there that contradicts what you see in this course, just ignore it. All right, just ignore it. um yeah, just make sure that this course overrides like everything you know. I know it sounds pretty weird that I'm saying that thing, but just that I thought a lot about it, and like most of this course is, I mean, comes from lots of years of experience. So like I've been coding since 2013, and even coding in Unity since 2013. So I've like I know lots of things about C#, about Unity, about pitfalls, and like I have still a lot to learn because it never stops. But for those that have less than a decade of experience, I'm pretty sure a lot of things from this course will help you. So um, if you find some information that's conflicting with what I say in some other place, just either ignore it or just tell me, and I will just learn something new, or I will just tell you, no, they are wrong, right? So just um, do one of those two things, or either ignore them, or just tell me that you have found something uh, that contradicts what I say, right? Because in all of those materials that I gave you, there will be a lot of things that will contradict what I say, right? And it won't contradict them intentionally, but just by omission, or just that maybe they don't think about some other things, or maybe they go too deep in some subjects, or yeah, you just take it with a grain of salt, everything you read from the reading list. And I put there like the order and everything, and I even put them here, right? You have the PDFs in the repo. um and they are free, so they are like you can find them, right? It's not like I pirated or whatever. So yeah, just read the readme, and maybe just take a look at one of them, right? Or two of them, just take a look, don't necessarily read them. now. And that's it. Let's see if there's something here. I don't know. Congrats, you're now a good Unity coder. Possibly. Yeah. And this is actually the reality. Yeah, that's like I said in the beginning, at the beginning of this course. So be a good Googler or LLMer, right? And we'll have a course about AI tools after this one. And this will be much shorter and the sessions will be shorter and the course itself will be much shorter. And yeah, just stay tuned for that one as well. See you tomorrow. Thanks for all the like all two of you on YouTube, two concurrent viewers. Uh yeah. See you tomorrow, guys. Thank you and have a nice evening wherever you are, or a nice day or morning. See you.